free course Unit 00 Goals and Introduction. Pretensions of this blockchain course. The objectives of this course are the following. 1. To know the origin and introductory characteristics of the blockchain. 2. To know the crucial people and literal data related to the emergence of the blockchain. 3. To know what's Bitcoin and its significance within the blockchain world. 4. To understand the difference between Bitcoin and blockchain. 5. To learn what Ethereum is and what the crucial differences are with respect to Bitcoin. 6. Understand how smart contracts work, their counter-accusations and possible executions. General introduction to this blockchain course. In this first module we will take a brief literal overview of the most important events that served as the base for the emergence of the blockchain, the most important people involved in its birth and perpetration, where it was perpetration, where this technology began to be enforced and its part in smart contracts. The blockchain is called to be one of the greatest revolutions that the human being is going to experience throughout the 21st century. However, before going into detail about how this technology works and what makes it so revolutionary, it is interesting to review the history that has been hidden since its creation, since it is really interesting, containing, to this day, mysteries that they have finished solving. Blockchain Course Unit 01, Startup of the Blockchain. There are three crucial names in the birth of the blockchain but which, however, are very little known beyond the most expert circles related to this technology. The first two are Stuart Haber and W. Scott Stornetta, who in 1991 laid the foundations on which the first functional blockchain would be created shortly after. These bases were presented in a study called How to Timestamp a Digital Document or How to Make a Timestamp on a Digital Document, where they sought mechanisms to improve the security of digital documents by creating timestamps that would prevent the documents from being manipulated or modified. The system that the two finally created was the blockchain, which would contain digital documents protected with a cryptographic key that would make their manipulation practically impossible. A year later, in 1992, they incorporated into the design a fundamental part for the later arrival of the blockchain as we know it today, the Merkle trees. The design of these trees was created by Ralph Merkle in the year 1979, in order to streamline the process of verifying large amounts of data. To create this, Merkle created a data structuring by strata where each existing node was related to a unique root associated with it called Merkle root, where each node must have a unique identifier which is called hash, a term that we will go deeper into in Module 2. Once each node has its own hash, they are concatenated in pairs and the result of this sum is assigned a new identifier. This process is repeated until there are no more pairs to associate, resulting in the main hash or Merkle root. As we mentioned at the beginning, Merkle sought to speed up the verification process of large amounts of data using this system. However, not only did it achieve this, but it also managed to give the entire structure an extraordinary level of security, since, due to the way hashing processes operate, any modification, however small, of the content would result in a totally different identifier and would therefore end up modifying the root itself due to the chain effect. As we have seen, the Merkle tree was a key incorporation in the first blockchain designed by Haber and Stornetta, thus giving Merkle a fundamental role in the creation of the blockchain, being the third key name in the history of its birth. The foundations of the technology were already in place, however, it would still take several years before it was finally applied for the first time. In 1998, Nick Szabo, a computer scientist and cryptographer, designed BitGold, which consisted of a decentralized digital currency whose structure was based on the participation of different agents who used the computing power of a computer to solve a series of cryptographic puzzles. When an agent in the network solves one of the puzzles, the solution is sent to a public registry and is associated with the solver. The solution, in turn, generates new coins and forms part of the next puzzle to be solved, thus creating a chain where each new link created depends on the previous one. This aspect is a fundamental part of the design, allowing all participants to verify the solutions to the puzzles and, if the majority agree, move on to the next one. The problem for Szabo started when designing the digital currency transactions, as he ran into the wall of double spending, which is an attack by which a cybercriminal can use the same currency as many times as he wants due to the very decentralized design of the network. This is why BitGold never became a reality, although, as we shall see, it laid the groundwork for another digital currency that would emerge a decade later. It was not until 2004 when computer scientist and crypto activist Hal Finney created a system called Reusable Proof of Work or RPOW, which solved the double spending problem that Szabo ran headlong into. The main design of the RPOW is to perform a moderately difficult job on the client side and easy to verify on the server side. The proof of work performed is called a POW token and has a limited form of sequential reuse. This allows a POW token to be used once, then halfini. Source N. Wikipedia. Org 9 exchange it for a new one that could be used again only once and then exchanged again in a process that we can repeat as many times as we want. This is why the RPOW solved the problem of double spending since, for example, if a sender wanted to send a coin to a recipient, as soon as that coin was sent to the receiver the sender would spend the use of his coin and would not be able to use it again. RPOW was the last piece of the puzzle that was missing so that, 4 years later, a link appeared in a cryptography forum redirecting to a white paper written under the pseudonym of Satoshi Nakamoto entitled Bitcoin, a peer-to-peer electronic cash system. Blockchain Course Unit 02, the first implementation, Bitcoin. Satoshi Nakamoto's publication appeared on October 31, 2008 and detailed the operation of a peer-to-peer network to create a system for electronic transactions without relying on trust, and to carry out this type of transactions he proposed the creation of a digital currency called Bitcoin. The basis on which Nakamoto relied to record Bitcoin network transactions was the blockchain technology. This blockchain would serve as a public ledger where anyone could consult or download it and where each and every transaction is recorded in blocks or, to continue with the simile, in pages. Once the block's memory is full, it is added to the chain as a sequential link. This ledger is not only used to record and consult transactions, but is also essential for validating them and relaying them to the other nodes, computers, that make up the network. All this information is not stored on a single server, but is stored by all the nodes that make up the network. It is a decentralized network, making it almost impossible to hack or steal the data. The only way to hack the network would be to control most of the nodes, which is a practically impossible task. Another interesting feature of Bitcoin is block mining, which is based on what Szabo already proposed with BitGold. Such mining is called the process by which all members of the network who are willing to participate in solving the cryptographic puzzle, which is nothing more than complex mathematical equations. Once one of the miners solves it, he or she sends the solution to the rest of the miners and nodes in the network who must check if it has been solved correctly. If there is consensus and most of the nodes agree, the miner who solved the equation adds a new block to the existing chain and receives an amount of bitcoins as a prize. This amount, which started as 50 bitcoins and whose first block and prize was mined by Satoshi Nakamoto himself, is reduced by half every 4 years. This process is called halving. Currently, after the halving in May 2020, the reward per block is 6.25 bitcoins and a new one is generated approximately every 10 minutes. The last halving will be in the year 2144 and there will be 20,999,999,9993 bitcoins in circulation, which gives a finite character to this digital currency and for which, among other things, its value has multiplied exponentially in recent years. The first transaction of the Bitcoin network took place on January 12, 2009 between Satoshi Nakamoto and the aforementioned Hal Finney, who not only helped with the creation of RPOW, but was a true enthusiast and advocate of this technology, claiming to be totally fascinated by what Bitcoin was proposing. In 2013, Finney himself explained in Bitcoin Talk his close relationship with Nakamoto and how they interacted to correct the errors they were finding. When Satoshi first announced the release of the software, I downloaded it immediately. I think I was the first person, along with Nakamoto, to run Bitcoin. I mined block 70-something, and received the first Bitcoin transaction, 10 Bitcoins that Satoshi sent me as proof. I had an email conversation with him over the next few days, where for the most part I was informing him of bugs so he could fix them. At that time, Bitcoin had no value, although that soon changed as the idea of this type of decentralized currency was spreading through the network, and many people were joining the trend and mining the currency and exchanging it in forums as a test. Between February and May 2010 the value of Bitcoin reached $0.003 and on May 22 of the same year, the first transaction for a good was made. This good consisted of 2 pizzas that the user Laszlo Haynek bought in Jacksonville, Florida, in exchange for 10,000 BTC. The purchase of these 2 pizzas has become a big event today and they call it Bitcoin Pizza Day. Laszlo wrote on Bitcoin Talk his request. I'll pay 10,000 Bitcoins for a couple of pizzas, maybe 2 large ones, so I'll have some left for the next day. I like to leave some pizza to eat later. You can make the pizza yourself and bring it to my house or order it from somewhere with delivery, but what I want is to have the food brought to me in exchange for Bitcoins without me having to order or prepare it myself. It's like ordering a breakfast plate at a hotel or something, they just bring you something to eat and you're happy. I like things like onions, peppers, sausage, mushrooms, tomatoes, sausage, etc., just standard stuff, nothing weird like fish, or anything like that. I also like regular cheese pizzas which can be cheaper to make or buy. If interested, let me know and we can work something out. Thank you, Laszlo. From that first transaction, the price of Bitcoin continued to rise over the years until on December 17, 2017, it reached its all-time high of $21,000 in South Korean exchanges, which put Bitcoin and the other cryptocurrencies that were created over the years on the world economic chessboard and stopped being seen as a thing of a few crazy people for many companies, banks, investment groups and large capitals to take it very much into account. So far we have focused on talking about how Bitcoin is structured and how it works. However, what is really important for the ordinary user is what are the advantages that this virtual currency can bring and what qualities make it so revolutionary. The main advantages that Bitcoin brings with respect to fiat money are: Bitcoin security. There is no need to provide personal information to make payments with Bitcoin, you only need a private key. The address of your wallet does not require personal information, so your personal data will always be protected. You cannot be charged commissions or hidden costs since every transaction is reflected in the blockchain. Transactions are irreversible, so it protects merchants from possible scams. Uncounterfeitable, you cannot create Bitcoin and add them to the network illegally because the constitution of the blockchain does not allow it. Takes up little space, a large amount of value can be accumulated in a simple file that can be transferred on your own cell phone. All transfers are anonymous and private, so no person can be identified by the wallet address number. Bitcoin payments. It can be used to transfer value from one account to another anytime, anywhere by simply holding your wallet as long as you have an internet connection. There is no limit to the amount and it is divisible to 8 decimal places. The person who has the wallet is the only responsible for its content without any authority or private entity having access or control over it. There are no intermediaries in the operations, since it is done point to point. The fees are very low compared to the classic methods. Payments are made quickly. Bitcoin transparency. The blockchain is public and can be verified by anyone at any time. The system cannot be manipulated by anyone as it is cryptographically protected. It is possible to know the amount of Bitcoins accumulated in any wallet while maintaining the anonymity of the owner. Despite all these advantages that Bitcoin can bring with respect to the fiat monetary system, it is not perfect and has some disadvantages that are also necessary to know. Knowledge. Despite having gained great fame in recent years, it is still a technology that few people know about. Its use is still somewhat complex for most people, although the level required for access is increasingly being reduced. There are few companies that accept it as a means of payment due to the lack of knowledge, which makes its popularity difficult. Risks. The price of Bitcoin is extremely unstable and can gain or lose up to 40% in a single day. This instability makes it an unsuitable currency for payments. It is very sensitive to changes in its price due to rumors, events or news related to it. There is still no clear legislation on cryptocurrencies, so the price is very manipulable by large investment groups. The issuance limit prevents the loss of value of the currency, but, on the contrary, it may incentivize people not to spend them and just accumulate. Beyond these advantages and disadvantages, the creation of Bitcoin has opened a new door to explore in the global economy and may, in time, become a fully implemented and socially accepted system. It is curious that a technology of this type, with the future applications that it has and that is called by many to be the digital gold, it is still not known who created it. Satoshi Nakamoto, we have already seen that it is a pseudonym, but shortly after its publication and testing with Finney in 2008, it disappeared without, to this day, we know who is really hiding under that name. As a final anecdote, in 2013 Bitslog published a detailed analysis of the amount of bitcoins that could be in Nakamoto's possession, the result being 1,148,000 BTC, which would be equivalent today to about $12.6 billion, making him one of the world's largest fortunes. Blockchain Course Unit Number 03, Blockchain 2.0. The first application of the blockchain was through Bitcoin and shortly after in many other cryptocurrencies that emerged around it. In 2016 there were around 70 digital currencies and by 2020 there will be more than 2,800. One of the reasons for this significant increase was the large number of initial coin offerings, ECOs, that took place in those years. An ECO is nothing more than a way to finance the birth of a coin in exchange, usually, for some advantage provided to those first buyers. The era of cryptocurrencies. It is because of this that this first stage is called the era of cryptocurrencies or blockchain 1.0. Where the use of this technology was only focused on the creation of different digital currencies with various uses and applications that tried to improve or solve some inefficiencies of Bitcoin. However, in most cases, they were only speculative projects where they sought to make money quickly, thanks to an unregulated market where almost anything went. The partnership between blockchain and Bitcoin has caused many people to end up thinking that they are the same. However, as we have seen above, blockchain is much more than a simple digital currency and has much more extensive and varied applications. Around 2014, many companies began to realize these possible applications and started to invest large amounts of money betting on this technology and on its great capabilities, looking for ways to adapt it to different sectors to benefit from all the advantages it could bring them, which, many of them, would make the difference with respect to their competition. Since then, blockchain applications and platforms have not stopped growing and improving, reaching a certain degree of maturity in their life cycle, and from the level of implementation that continues to this day, this will continue to be maintained over time. This ultimate separation of the blockchain and Bitcoin concept is what Blockchain 2.0 is being called and is being touted as the democratization of the internet, and will no longer be a thing of a few geeks but will take a pragmatic approach to solving a myriad of business and government problems that exist in our world today. One such company is the tech giant IBM, which has already created its own blockchain ecosystem, becoming one of the biggest forerunners of this technology. For example, IBM Food Trust is a complete ecosystem of producers, suppliers, manufacturers and retailers that allows tracking fresh seafood all the way to its deliveries to the restaurant, providing all the details of inventory, products and geolocation data of international food imports, all with a secure and reliable enterprise-level blockchain platform. Recent research has identified more than 90 use cases for enterprise applications of blockchain across industries. Many near-term use cases will involve the application of blockchain to reduce costs associated with existing processes, such as the exchange of medical records between providers, insurers, researchers and patients. In these activities, blockchain can eliminate the need for middlemen and lower the administrative costs associated with record keeping. In the long term, blockchain could be used to improve fraud management, supply chain monitoring, cross-border payments, identity verification, and copyright or intellectual property protection, among many other things. Many companies and organizations are now supporting the development of blockchain business applications. The Linux Foundation has created Hyperledger, an open-source collaborative effort to develop blockchain technologies for multiple industries. Similarly, the company R3 is leading a large consortium that developed Corda, a blockchain platform for use in financial services and trading. Corporate investment in blockchain reached $1 billion in 2017 and is expected to grow at a compound annual growth rate of 50% through 2021. All this interest in blockchain enterprise applications recently increased with the advent of BaaS, which simplifies the creation of the complex 5-layer blockchain technology stack. Until last year, enterprise customers had to build individual layers themselves. Among other things, they had to customize existing digital accounting platforms, distributed computing platforms with base protocol and configurable functions. They also had to acquire and integrate data, define permissions, protocols and code software. Most companies simply lack the funds or in-house technology talent to be able to do all of this. The advent of BaaS. But what is BaaS? Blockchain as a service, BaaS, is the creation and management of cloud-based networks for companies in the business of creating blockchain applications. These third-party services are a relatively new development in the growing field of blockchain technology. BaaS is based on the software as a service, SaaS, model and works in much the same way, allowing customers to leverage all cloud-based solutions to be able to perform their own blockchain-related operations or build and host their own blockchain-based applications, while the cloud-based service provider keeps the infrastructure agile and operational. This development is an extremely interesting addition to the blockchain ecosystem, as it will enable and drive blockchain adoption across enterprises. Some of the major corporations offering BaaS services are Microsoft, which partnered with Consensys to introduce Ethereum blockchain as a service on Microsoft Azure in 2015. Amazon, which has created Amazon Managed Blockchain, a service that, as Amazon itself explains, makes it easy to create and manage scalable blockchain networks using open-source frameworks including Ethereum and Hyperledger Fabric. R3, which we've discussed previously, and Corda's creation. Pay Stand, which specializes in sending and receiving business-to-business payments. Consumers and businesses are increasingly beginning to learn about the blockchain, which is critical for mass acceptance and adoption. However, the problem to implement it now is stemming from the initial lack of awareness to the various difficulties in the form of technical complexities and large operational costs related in the creation, maintenance and configuration of blockchains. BaaS offers an external service provider to set up all the necessary blockchain infrastructure and technology in exchange for a monthly or annual fee. Once set up, it is the provider who continues to perform the complex operations that are hidden in the background for the customer. The BOS operator generally provides support services such as bandwidth management, appropriate resource allocation, hosting requirements and data security features. In short, the BOS operator frees the customer to focus on what really matters to them, the blockchain functionality. In fact, the function of a BOS provider is similar to that of a web hosting provider. Website creators create and run all website content on their own personal computers. They can hire support staff or sign up with a third-party hosting provider, and it is these third-party companies that take care of infrastructure and maintenance issues. BOS, therefore, can be of great help when it comes to starting to implement the blockchain in companies and in different industrial sectors. Where previously they would have to create and maintain their own blockchains, now they only have to outsource all this work, thus eliminating all the technical and economic barriers to its adoption. Blockchain Course Unit Number 04, Ethereum and Smart Contracts. Ethereum is the second most important network in the world of cryptocurrencies and blockchain, only after Bitcoin. Ethereum was created with the intention of improving some limitations of Bitcoin, which, as we have seen so far, is essentially just a decentralized monetary system, and thus taking blockchain technology and decentralization to another level. Like Bitcoin, Ethereum supports a peer-to-peer node network, meaning it is essentially a decentralized server managed by a large number of computers without a central administrator or middleman. There is a common misconception that often occurs in people new to cryptocurrencies, and that is to believe that the name Ethereum is what the coin is called, when it really belongs to the network. Nodes are rewarded in Ethereum's native currency called Ether, ETH, and the cost of operations is calculated in gas. The Ethereum network was invented by Vitalik Buterin, a young Russian-Canadian programming prodigy. In his white paper, which was released in 2013, he describes Ethereum as a blockchain-based decentralized mining network and software development platform all in one. What Vitalik intended by creating the Ethereum network was basically to extend the idea of the Bitcoin contract protocol, but with a much more ambitious idea, with the goal of facilitating the development of a complete ecosystem for open decentralized applications called dApps and smart contracts to build and run while eliminating the risk of third-party interference. Before the Ethereum network was launched in 2015, anyone who wanted to create a blockchain-based application had to build their own blockchain platform from scratch. But with Ethereum, developers can leverage its network infrastructure to create virtually any application imaginable. Lack of scalability. The Ethereum and Bitcoin platforms rely on a peer-to-peer network of nodes, and both use mining incentives to motivate them to grow or maintain those nodes on their platform. As a public blockchain, the Ethereum network aims to support as many users as possible. However, Ethereum runs on the same proof of work, PoW, protocol as Bitcoin, which means that computational power is needed, not only to produce new coins but also to process transactions and keep the entire ecosystem moving. This responsibility placed on each node becomes a problem as the Ethereum network attempts to grow or scale. Scalability is simply the ability of a network to grow in size and manage the increased demand. For the Ethereum blockchain network, each node contains the complete transaction history and updated ledger for account balances and contracts. As new blocks of transactional information are created, all nodes must store and update, which can cause serious issues with network speed. While scalability now represents a common headache for blockchain developers, the problem was first exposed on Ethereum network in 2017 when a dApp for creating crypto virtual cats called CryptoKitties became a viral success and crashed the entire network with more transactions than it could take on. The popularity of CryptoKitties caused the app to go from 1 million in transactions to 3 million in transactions in the space of one day, representing 20%, at the time, of all transactions on the network. In addition to the network losing speed dramatically, another effect was a significant increase in the price of transactions. Before we look at how Ethereum plans to evolve to solve this scalability problem, we need to focus on a concept that has already come up several times, and that was another reason why Ethereum revolutionized the blockchain: smart contracts. In 1996, Nick Szabo, whom we have mentioned at the beginning of the course, analyzing the structure and functioning of the ledger, observed that it could also be used to include smart contracts, or also called blockchain contracts. These contracts could be transformed into computer code, stored and replicated on the network while being monitored by the nodes of the blockchain itself. Similarly, it would also result in ledger entries, as does transferring money, receiving a product or service. So, what is the role of smart contracts? Smart contracts will help us to exchange products, goods, services, or anything else that has value in a transparent and conflict-free way, avoiding having to introduce an intermediary in the operation as we have had to do so far. For example, if you need to do any administrative procedure in a notary's office, you would have to go to the place and wait for a lawyer or notary, pay them and wait again to finish the management of any document. With smart contracts, it would be like going to a vending machine, inserting your digital currency and getting the document instantly, automatically associating it with your account. Similarly, smart contracts, apart from being the ones that define the terms of an agreement and the penalties around it as a traditional contract does, also enforces those obligations automatically. For example, let's imagine we need to sell a house. It's a fairly long and tedious process that requires a lot of paperwork and talking to different companies and people. That is why most people who decide to sell a house decide to hire the services of a real estate agency or real estate agent so that they are the ones who take care of acting as intermediaries, taking care of the negotiations, paperwork, showing the property and supervising the whole sale until closing an agreement, freeing us from all that ordeal. However, all this type of advantages that the real estate agencies or real estate agents provide us are not free, so we will have to subtract a substantial part from the final price of the property, that is to say, we are suffering a financial loss in exchange for obtaining this type of services. In this type of situation is where smart contracts can really be useful and totally revolutionize an entire industry, while making all processes much simpler. Another thing they solve, which is not unimportant, is the lack of trust in many actors in society. Smart contracts work based on the if-then principle, which means, following the example above, that only when the agreed amount is sent to the system the ownership of the house will be transferred to the buyer. Therefore, smart contracts also perform the function of escrow services, since both the ownership right and the money that will be finally paid for the property will be stored in the system and distributed at the same time to both the buyer and the seller. This whole process is at all times verified by all the member nodes of the network, which act as notaries of the process. This type of contract eliminates the need for an intermediary because trust between the parties is no longer an issue. There is no need for an intermediary. All the necessary functions that used to be performed by the real estate agency or the real estate agent can be pre-programmed in a smart contract, saving both the seller and the buyer a lot of money. We already know what a smart contract consists of and what advantages it has over traditional contracts. However, none of this would be of any use if the scalability of the network is not improved since, if smart contracts have a massive adoption, in a short time the whole system would collapse, so a significant improvement in the base of the Ethereum network is necessary. This upgrade is already underway and is referred to as Ethereum 2.0, Serenity. Starting in late 2019 and early 2020, Ethereum 2.0 is focusing on fixing the underlying problems of the blockchain platform. Currently, one of Ethereum's most burning issues is limited scalability. Compared to payment giants like Visa and MasterCard that can process around 60,000 transactions per second while Ethereum's network only has the capacity to process 15. As a possible solution, Ethereum developers will create a new blockchain alongside the current one to introduce new updates. One of these important updates is sharding, a process that divides data processing among multiple nodes, allowing for parallel transactions, information processing and storage, a new cryptocurrency, ETH2. Ethereum 2.0 will also feature the implementation of the POS, proof of stake, consensus algorithm, where what matters is whether or not you have coins and how many you have, and a new virtual machine that allows developers to code in multiple languages. While the fate of the current blockchain, Ethereum 1.0, is still undecided, developers expect Serenity to increase the security, efficiency and scalability of the network by potentially reaching 100,000 transactions per second. Blockchain Course Unit Number 05, Blockchain Structure and Operation. So far we have reviewed the history of the birth of the blockchain, stopping at the most transcendent moments of the same and giving some keys and concepts about its operation that are essential to minimally understand the operation of this technology. In this unit, however, we will delve in detail into the functioning of the blockchain and the parts that compose it, seeking a much deeper understanding of the blockchain. The goals of this unit are: to know the structure of a blockchain and the parts that compose it, to understand the mechanism of transactions in the blockchain, to learn about hash functions and what is their role, to know the meaning of mining in the blockchain environment and how it works, to understand the role of public key and private key, how they work and their importance in the blockchain ecosystem, to understand the concepts hard fork and soft fork and their differences. Operation and structure. Before we start going in depth, we can summarize what the blockchain is as a ledger that uses cryptography and rewards to record the transactions that are generated in its network in a reliable, secure and tamper-proof way. This feature allows you to perform transactions between different parties without the need for trust between them or a third party. Once we have a simple definition established, we will begin to unpack each part of the blockchain, establishing some primitives. Primitives are like the base material from which you build something. If you want to build a table, you will need wood, some screws or nails, a saw, a drill, paint, etc. Therefore, it would be wise to know how each one works before you build anything. The most basic part of a blockchain is precisely the blocks. These are what shape and build a blockchain. These blocks contain different types of data and basic information to maintain and continue with the structuring of the blockchain. When one of them is completed, it becomes an indivisible link and gives way to the generation of a new block. In this way, the entire network runs in a cycle and all data is stored permanently. Each block contains records of some or all recent transactions, and a reference to the block that preceded it, which, together with the point-to-point verification system, makes all transactions that are recorded in the blocks of the chain impossible for any user to change or delete. All this information contained in the blocks needs to be secure so that no one can access it to modify, steal or delete it, and that is where cryptography comes in. Cryptography is the study of techniques for communicating securely in the presence of third parties. Like so many other things related to modern technology, it was the military who carried out a great deal of cryptographic research to ensure secure communications between their troops without enemies being able to read their telegrams or radio messages, even if they intercepted them. However, the history of cryptography goes back much further. Cryptography comes from Greek and is composed of kryptos, secret, and graphi, graph or writing, which literally means secret writing. It is estimated that the origin of cryptography dates back to approximately 2000 BC as stone inscriptions, cuneiform tablets and papyri survive today that show that the ancient Egyptians, Hebrews, Babylonians and Assyrians devised proto-cryptographic systems both to deny information to the uninitiated and to enhance its meaning when revealed. It is believed that the first person to use a cipher considered modern was Julius Caesar, 100 BC to 44 BC, who used this type of technique when he had to communicate with officials or different governors because he did not trust his messengers. Because of this, he devised a simple but very effective system, which consisted of substituting each letter of the text of his messages with another letter that was placed 3 positions ahead. Since the time of Julius Caesar, cryptography has evolved enormously, always looking for new methods of safeguarding information in the most effective way possible. Today, modern cryptography has 4 well-defined goals. Confidentiality. The information in the message cannot be understood by anyone other than the intended recipient. Integrity. By encrypting the message, it cannot be altered both in storage and on its way to the receiver without detection of such alteration. Non-repudiation. The sender of the information cannot later disassociate himself from the transmission and creation of the information sent. Authentication. The origin and destination of the information can be confirmed by the sender and receiver, as can their identities. There are many procedures and protocols that try to fulfill all these goals, which are called cryptosystems. These cryptosystems, in addition to meeting these objectives, also focuses on human behavior. For example, the choice of passwords difficult to guess with a number of certain characteristics, logging out of systems when you stop using a computer or not sharing sensitive information with people outside our personal or work environment. Because we live in the internet age where all our data and information travels around the world, modern cryptography is used in practically everything we do, from the websites we visit to credit card chips to the passwords of our computers, mobiles and tablets. In all these cases, the goal is the same, to prevent not so much that the message is captured, but that its content is unreadable by the interceptor. Hash functions. Once we know the procedure used to hide the information, we will analyze the method used to encrypt the information within the blocks of the blockchain. To achieve this goal, a mathematical function called hash function is used to encrypt the data. This hash function has 3 basic properties. 1. Its input can be of any size. For example, you could use a phrase like "my car is blue" as input, or, conversely, you could use the full text of Don Quixote and both would work. 2. Using whatever size we want as input, the output size is the same and is determined by the same hashing algorithm being used. To keep it simple, we'll use 256-bit output, since that's the same as what Bitcoin uses. Whether you entered the phrase "my car is blue" as input or used the entire text of Don Quixote, both would produce an output with the same size. Using an algorithm called SHA-256, which is the one used by Bitcoin, the phrase "my car is blue" generates the output. 1447312D7A7894E07903D2099F60B2B8C8614D68D9BA20D0991E239AC212FC0. The first 407 words of Don Quixote de la Mancha using the SHA-256 algorithm result in F0 ABF 85 A5 EB3 A3 A4 873 883 B62 F000 A1672164978 8 B925 E63 E89924 DC080. Although the Quixote input has 403 more words, you get the same output size, which is extremely useful. 3. It must be computationally efficient. For any given input size, it must be able to compute the output in a reasonable amount of time. If I wanted to use the entire text of Don Quixote as input, the output should be given in a reasonable amount of time. The properties described above are for a general type of hash function. General hash functions allow you to map information that occupies a large space to a much smaller space and can be useful for storing and working with different types of data. However, we will focus on cryptographic hash functions, since those are the ones used in blockchains. Apart from the above properties, a cryptographic hash function requires 3 additional properties: hiding, puzzle-friendly, and collision resistance. Concealment. Hashes may look random, but they are actually deterministic. Therefore, their outputs are reproducible, so that whenever the same input is used, the same output will always be obtained. This means that 2 different parties who know the input can verify that the other party also knows the input by showing their hash to the other party. Therefore, the first property we want for a cryptographic hash function is that it should be hidden. This means that, if the output is given to someone, there is no way for that person to find out what the input was. That is, there is no way for an outside observer to know that
1444731D7A7894E079003D209F60B2B8C8614D69B20D0991E239AC212FC0 means my car is blue. However, I do know that the entry is my car is blue, then I can easily verify whether or not you know that by checking your hash. The fact that if someone else sees the hash they can't use it to figure out the input, allows those who do know the input to communicate securely in a public channel using the hashed output without worrying that a third party might figure it out. Puzzle-friendly. The second property we need is that it be puzzle-friendly. This means that, if someone wanted to generate a hash with the same result as my car is blue, it is practically impossible to find another input value that achieves exactly this same result. The algorithm that would be needed to generate the hash would be to try all possible strings, first in order of length and then in alphabetical order, until one is obtained that has the same value. The odds of this happening are so high that it is more likely that an asteroid would hit the Earth making us disappear. In other words, cryptographic hash functions are extremely difficult to reverse, and it is precisely this that makes the main difference between a cryptographic hash with a hash used in data structures or a compression algorithm. This is also part of the blockchain's arms race, as hackers are always looking to improve methods for inventing hash functions, so cryptographers, for their part, always have to be looking for better hash functions. Having this capability is critical because, as we already know, the blockchain is a ledger that must be tamper-proof, and this property of puzzle-friendly is what enables this. If I wanted to replace an entry such as my car is blue with another one, it should be impossible to do so without other participants knowing about the existence of that change. If we use a good cryptographic hash function, even the slightest changes that could be made to an input would result in completely different outputs, making the input resistant to manipulation. In short, cryptographic hash functions appear random, cannot be reversed, and hide inputs, but, at the same time, they are completely deterministic, and it is precisely this that makes them so extremely useful. Transitive hash functions within the blockchain. So far we have seen how hashing works with a single piece of information such as words in a ledger or a password. What if we wanted to hash collections of data such as a bunch of documents or a sequence of transactions? Let's start with a linear sequence of things we want to hash consecutively. We start, for example, with a piece of data called A, which when we hash we get A1. Now we want to mix B, so we just add B, A1 plus B, and hash everything together. Now we get a new hash which we will call B1 and which is information about A and B. So, what we need is a hash function which in case of changing something about A or B results in a different final hash. This is a transitive hash function. A blockchain is a chain of hashes. When talking about blockchains, one of the phrases that is used a lot and that we have already mentioned several times, is minimize trust. Hashes in general, and hash pointers in particular, are a central component of this property that allows us to minimize trust. A hash pointer is just a hash that points to some other data structure such as a previous block in the blockchain. If we had a blockchain of 100 blocks and the 10th block contained the hash of the entire book of Don Quixote, and we changed one letter in that book,
it would change the hash pointer in that block and thus in all subsequent blocks.
Hash pointers ensure the integrity of the ledger, i.e., that it has not been modified.
Blockchains have been called triple-entry bookkeeping because this hash pointer data structure is another, more difficult to forge way to ensure that the ledger reflects reality. Merkle trees. Now, what if we want a hash not just in a linear sequence, but in a sequence of sets like Bitcoin transactions in its block sequence? For this we need a new rule on how to traverse each data set, reducing the problem, again, to encrypting a consecutive series of things, A1, B1, etc. A Merkle tree, which we've already talked about, is exactly this. It allows us to group blocks of data and group them into a structure that looks like a tree branch with leaves. In the same way that happens in a blockchain, it is enough to know the hash point of the root of the tree, or Merkle root, to be able to check if any of the data in the rest of the tree has been manipulated. If one bit is changed, in one transaction, it changes every subsequent hash and the tampering would be revealed. Using a Merkle tree is preferable to using only a summary of all transactions, because it allows a much faster and simpler test of whether a particular transaction is included in the set of all transactions. Collision resistance. Finally, we will address the third and last property required by a cryptographic hash function, collision resistance. A collision is when two different inputs produce the same output. While the output size will be the same, the output itself will not be identical to other outputs. My car is blue and the entire text of Don Quixote produce output of the same size, but the characters are different. If they were to produce exactly the same output and we were to send that ciphertext to another person, that person, when decoding it, would not know which is the correct message, my car is blue or the full text of Don Quixote. It should also be noted that two similar inputs cannot result in similar outputs. For example, the Quixote hash is completely different from the Quixote hash by adding an S to any word in the first sentence of the book. Continuing with the example, we have already seen that if we use SHA 256 on the first 407 words of the book of Don Quixote de la Mancha, it produces the hash F0ABF85A5EB3A3A4873883B62F000A1672168B925E63E899224DC080. If we add an S in the first sentence, it would be in a place in the manchas and leaving the rest of the text exactly the same. The hash it produces is AB209BD3B97BD DFF95286B041643C263E381E3ED5C10E44674046407. This is much like how two close starting points in a chaotic system very quickly lead to two completely different future trajectories. It is this chaotic encoding property of hash functions that creates collision resistance. The outputs appear random and are therefore unlikely to collide, but they can map infinity to finite space, allowing us to compress data. This is particularly important if you are sending money. The public key of a wallet is produced from the private key using a cryptographic hash function. It is not desirable that someone else can reverse engineer and thereby obtain your public key to discover your private key, and thereby gain control of all funds. A hash function is considered collision resistant if it is not possible to find a collision. In theory, we know they exist because the number of inputs is infinite, but the number of outputs is finite. There are only so many ways to organize 64 characters. However, in practice, the SHA 256 cryptographic hash function is resistant to collisions because no one has yet encountered one and the odds of it happening are astronomical. To give you an idea of how difficult this would be for this to happen, if every computer made by mankind had been trying to find a collision since the beginning of the universe, the odds of them finding one are lower than the odds of the Earth being destroyed by a giant meteorite in the next 2 seconds. The proof of work. Satoshi Nakamoto's greatest innovation, whoever he was to create a new rule and that was added to the existing ones. When a new set of transactions, a block, is added to the existing chain, an extremely difficult and impossible to skip mathematical problem must be solved. This task is done by so-called miners and consists of finding the origin that gives rise to a given hash. When the origin is finally found, a new block is added to the chain and whoever has solved the riddle receives a reward in the form of the coin being mined. Solving the problem is what is called proof of work, which is a test of how much energy was used in trying to solve the problem. For cryptographers, the invention of this proof of work blockchain was Satoshi Nakamoto's biggest breakthrough. As both the blockchain proof of work and Bitcoin itself become more valuable, miners make more money, which incentivizes more miners to participate in the network, causing the difficulty of the problem to increase. The blockchain with the proofs of work already accumulated is considered the true blockchain and is currently about 300 gigabytes in size, which can give us an idea of how much energy it has taken to generate all this amount of data. The only benefit of having this large size is that, if someone wanted to forge the Bitcoin blockchain, they would have to spend the same amount of energy that has been spent so far to generate all the blocks that make up the Bitcoin blockchain with the same difficulty used in each of them, which virtually ensures that this will never happen. Today, it would cost billions of euros to buy enough hardware and electricity to rewrite the Bitcoin blockchain from scratch. Blockchain Course Unit Number 06, Transactions and Mining. To understand how transactions work in the blockchain, we must first be clear about two fundamental concepts, the public key and the private key. The concept of public and private keys. Public key cryptography, PKC, is based on trapdoor functions, which consists of a mathematical operation that is very simple to solve in one sense, but almost impossible to solve in the other, making it almost impossible to decrypt. Solving this type of problem involves calculating the correct answer, and this takes computers enormous amounts of time, even thousands of years. Therefore, some mathematical practices, such as factoring prime numbers, are not productive for reverse engineering. PKC uses digital signatures to secure private communications that have been made over a public channel and could be intercepted by anyone. If we apply the same in the field of cryptocurrencies, the main objective is to analyze if it is a forgery, checking if the signature of the owner of the funds is present in the transaction made. When holding cryptocurrencies, what we actually have is a private key. This private key is what unlocks the account and allows us to make use of all the cryptocurrencies that are associated with it, and this same right of use is what makes it so extremely delicate, so we must take special care with its protection against theft or loss by storing them in safe places and making backup copies, for example. This private key is not the only one that exists, we also have a public key and a cryptographic union between these two keys. In order to recover the public key we will need our private key, however, we cannot do the opposite. Private key and public key. An easy relation that we can establish to understand the difference between one key and the other would be that the public keys would be the equivalent of our email, while the private key would be our password. A person can generate as many public keys as he or she wants, addresses, from his/her private key, which is unique and serves as a password. These addresses will be visible to any user of the network since they will be the ones that person will use to send and receive his assets, for example, Bitcoin, but only this person will be able to enter and manage these addresses because he is the one who has the private key that gives him access to all of them. Process of a transaction. In a transaction, the way to prove that we are the ones who have carried out any operation is thanks to our private key, which acts as a digital signature. If we need to send a message to another person through a channel that is not private, anyone could be listening, so we could use our private key to encrypt the message and be able to send it with total security. In this process, we would create an output hash with our message that would be sent to our receiver using the receiver's public key. Finally, once the receiver has the message in his possession, he could decrypt it using the output hash and the private key. Any person trying to intercept the sent message would only have the public key, so it would be impossible to decrypt the message. Cryptographic transaction. A Bitcoin transaction is the simple act of sending an amount of Bitcoins from one address to another. We can use an example to understand and see in more detail the procedure. John sends from one of his public addresses 1 BTC to another public address of any other user. Before being sent, this transaction is signed with John's private key to record who the transaction belongs to and the amount sent. The nodes that make up the Bitcoin network automatically verify and validate the transaction to ensure that it is not a forgery by making use of established consensus rules and cryptographic proof that the public and private key pair is valid. This process results in an extremely secure transaction that is impossible to forge. Once the funds reach the destination user, this transaction starts to be confirmed by all nodes and is recorded in the blockchain, being totally irreversible. These addresses, therefore, can be used publicly without fear of exposing our assets, as a current account where we can receive or make transfers. Mining. So far we have mentioned mining on several occasions and at some points we have delved into some aspects. However, the concept of mining can create some confusion, so to clarify it we will use, once again, the Bitcoin blockchain as an example throughout this part of the syllabus. Mining is not about creating new Bitcoins. The mining process is what makes the blockchain able to be a fully decentralized system. It gives security to the system and enables it without a central authority. We must clearly differentiate mining from the new Bitcoins that are generated and delivered to the miners by the actual process they perform. Before we continue, let's review some things we already know about mining. The miners are in charge of validating all the new transactions that are generated, registering them in the ledger, this procedure being irreversible. The blocks containing all transactions are mined approximately every 10 minutes. During this time, all miners are constantly competing to be the first to solve a mathematical equation based on a hash algorithm which is called proof of work, POW. This proof is the demonstration that a miner has spent a lot of time and resources to solve the problem. When a block is solved, the contained transactions are considered confirmed and the Bitcoin in question can be spent on the transactions. Therefore, if we expect to receive Bitcoins in our wallet, our transaction will take approximately 10 minutes to be confirmed. We already know that miners receive a reward in the form of Bitcoins when they find the solution to the complex mathematical problem posed. However, it is not the only reward they are eligible for. There are actually two types of rewards for miners: new Bitcoins or transaction fees. Miners are needed to send Bitcoins through the network confirming the transactions that are being made. To perform this action, we can pay as a tip the amount of Bitcoins we want, although it is advisable nowadays to establish this tip around 0.0003 BTC. If we make standard transactions so that our transaction is carried out as quickly as possible, since each miner has a certain number of transactions that can be carried out and, therefore, prioritizes depending on the amounts that each user has given them for carrying out their transaction. It should be noted that, as the reward per block to the miners decreases, the transaction fees will increase to compensate for their work in maintaining the network. Therefore, after the year 2140, the winning miner will only receive transaction fees as a reward. Having said all this, the next step would be to understand how in a vast network full of nodes that, moreover, do not have any kind of trust with each other, can reach a consensus on who owns one or another Bitcoin. To explain this process, we will take as an example a real block, the number 641,587, for example. We will follow the life cycle of this block from its creation to its final validation, which was solved by Juan, the person in the example above, who is also involved in mining. Juan competed to try to win the battle to validate block 641,586, however, in the end, it was another miner who managed to solve it. Once block 641,586 was mined, Juan began to create a candidate block, which would become block 641,587, but not before updating his copy of the blockchain. Juan's node, while it is in the process of searching for the POW for a block, keeps receiving new transactions that it accumulates and adds to the memory group or transaction group. All these transactions wait in these groups until it is time for them to be validated and added to a new block. Once the node receives the notification that the current block has a valid POW, the process of creating a new candidate block, which does not yet have a valid POW, with the transactions mentioned above begins. We can see that block 641,587 has 2,196 transactions inside it. This number refers to the number of transactions that were present in John's transaction group when creating his candidate block. We can see that block 641,587 has within it 2,196 transactions. This number refers to the number of transactions that were present in John's transaction group when creating his candidate block. The first thing Juan's node does is to create the Coinbase transaction. This transaction is generated to pay the miner his reward for mining the block, or what is the same, for finding the proof of work, and is therefore directed to the miner's own wallet, blue box, in our example Juan. This type of transaction is totally different from the rest because the reward Bitcoins are created out of thin air, they do not come from someone's wallet. The transaction fees are also calculated by the nodes in the block. John's reward equals reward per mining block plus transaction fees. In this case, we can see that the reward per block is 6.25 BTC and the transaction fee is equal to 0.80450543 BTC. 6.25 plus 0.80450543 equals 7.05450543 BTC. Building the block header. The creation of a proper block header is the responsibility of the node itself and is composed of several pieces of information. The root of the Merkle tree. The hash of the previous block. The data on which the mining competition will be based. The data for the mining competition, in turn, is a set of metadata containing the version number of the software being used in order to be able to check equalizations and protocols. The elapsed seconds in Unix time elapsed from midnight on January 1, 1970, until the creation of the block. Target of the POW algorithm for this block. Nonce, counter used for the POW algorithm. The version when block 641,587 was extracted is 0 by 3400, which is represented in Little Endian format in 4 bytes. The timestamp is the number of seconds elapsed from January 1, 1970 to the date and time the block was created.
Knowing that the date of the block is July 31, 2020 and the time 11:01, we can use a Unix epoch conversion tool, e.g. https://www.
epochconverter.com/ and get 1,596,193,260,000 seconds. It is the network itself that marks the goal and, therefore, that establishes that a hash is valid or not. In case a hash is higher than the marked target, then it is considered as invalid, and that is what is used to calculate the difficulty. In the block we have taken for the example, the difficulty is 16,847,561,611,550.27. Let's analyze the hash of the block.
00000000001F9A0B6D343C0499F984D7787E4CO16FD28FF00C0B002. The first 19 zeros mark the difficulty, so a hash with less than 19 leading zeros would not be valid. The last piece of information is the nonce, which is a 32-bit number that starts as 0. Once the competition begins, the miners assign random nonces in an attempt to find a valid hash. This is the only value that the miners change. Once all this is done, John can extract the block. As we have seen above, the node must find a hash for the nonce that is below the target. Therefore, the 32-bit size of the nonce means that there are 4 billion possible combinations. Although technically, it is much larger because of something called an additional nonce. This is an additional space for a longer nonce, which means it can have tens of billions of combinations. In Bitcoin, we already saw that the SHA-256 hash function is used, which produces a 256 bits long output, and that with 2 different inputs, collision, it is impossible to calculate the same hash, just as it is also impossible to predict the output of any data in advance. We know that mining consists of finding a nonce that produces a hash with a value less than or equal to that set by the difficulty. Because all the information is accessible to anyone, it is quite easy to be able to check whether the hash found is valid or otherwise invalid. The POW in Bitcoin is not a static parameter, but changes every 2016 blocks so that the goal of mining one block every 10 minutes or so is achieved. This is because, if it were static, with the improvement of technology and computing power, those 10 minutes would be progressively reduced and the block limit would be reached much earlier than established. The way to readjust the difficulty is simple. Multiply the 2016 blocks by the expected time, i.e., 10 minutes, and we get a result of 20,160 minutes.
This is the time it should have taken to extract those 2016 blocks. If the actual time has been less, then the difficulty is readjusted to keep it within those 10 minutes. Having explained the latter, let's suppose that John's node starts up and after about 10 minutes, finds a hash that turns out to be valid. We can see that the nonce used was 370,749,008. Once the node has the valid hash, it immediately transmits it to all peers so that they can validate it. Valid data includes the block header hash smaller than the target, a block size within the allowed limits, the timestamp of the block, a first Coinbase transaction, only the first one, a valid reward. All transactions within the blocks that are valid, they also have a checklist of their own. All new blocks are validated independently by each node following the same rules. This process of reaching consensus in a decentralized manner ensures that no node in the network can cheat in any way. Once it is established that the block is valid, all the miners that make up the network will update their copy of blockchain to incorporate the new block 641,587 and will use the hash of the block that Juan resolved in order to extract block 641,588. This closes the cycle of a block to start again right after the next one, as we have seen. The problem with this mining process is that, due to the large computational power required to find a valid hash, it makes it almost impossible to achieve the reward if attempted individually. This is where the so-called pools come in, which is nothing more than a mining pool with a coordinator in charge of organizing the miners. The coordinator will make sure that the miners use different values for the nodes so that they don't waste hashing power by trying to create the same blocks. These coordinators will also be responsible for dividing the rewards and paying them to the participants. These mining groups began to emerge as the difficulty of mining increased to the point where it became unprofitable for a single miner to attempt to solve a block due to the enormous amount of time and energy cost involved. As the value of the different cryptocurrencies has increased, many people have entered the mining world, causing an increase in competition and the difficulty of block resolution. These unions have obvious advantages. In the groups, all members join their computing power to solve the block, so it is solved much earlier, shortening the time ostensibly and having many more chances that any member of the group can solve the block. Once solved, each miner receives a percentage of the reward generated by solving the block depending on his contribution. Although we can find pools all over the world, most of them are concentrated in China and in countries where the price of electricity is very low, as this way they manage to increase considerably the profitability of mining operations. Within these mining groups there are different ways or methods of distributing rewards. Pay per share, PPS. The miner receives the payment corresponding to his contribution immediately from the total amount belonging to the group. An advantage of this method is that the balance can be withdrawn whenever the miner requires it without waiting. Another advantage is that the amounts that the miner will receive will be much more stable over time without many differences between them. Proportional. Miners receive shares based on the contribution they have made to the group. Once the group gets the reward, it is divided among all the miners depending on the amount of shares each of them has. Pay per last N shares, PPLNS. This method is similar to the proportional method, however, the reward received by the miners is based on X number of last shares instead of the number of shares received when solving the last block. The shares given to the miners are the same and the amount will be higher if the block is solved in less time than if it takes more. Geometric. In this method, each share sent by a miner receives a score depending on the connection time of the miner. When the block is solved and the group gets the reward, it is divided and distributed among all depending on the score. In this case, the score given to each action does not vary depending on how long it takes to solve the block of that round. Multi-pool mining. This type of group mining is based on achieving the highest possible profitability by changing the mining between different cryptocurrencies. These changes will be made depending on different factors: the value of the coin at the time of mining, the time required to mine the block, the number of miners involved in the resolution of the block. Blockchain Course Unit Number 07, Hard Fork and Soft Fork. The term fork is used when a blockchain undergoes a fork resulting in the generation of two blockchains that will cease to have any relationship between them from that moment on. There are several types of these forks depending on the scenario in which they occur, the most common being the hard fork and the soft fork, although there are some others such as the temporary fork and the accidental fork. Before explaining the differences between these forks, let's first look at the reasons why they can occur. Blockchain technology is interesting because each of them provides a set of rules that make it work. Miners, clients and nodes agree on their own to join, stay and protect a network because they fully understand and accept the rules. Updating any computer application creates a new version, and blockchain technology is no exception. However, in this case, because of its own decentralized nature, it has many peculiarities. Access to the internet and the increase of innovation in different fields of technology allows anyone to be aware of what can be done by applying a series of improvements on a software. If, for example, we were Bitcoin enthusiasts, we could simply submit a BIP, a Bitcoin improvement proposal, which is simply a suggestion of how to improve one or more features of the software. If enough people like our idea, they can ask for that software improvement to be implemented. But things can get complicated when people already inside a network decide to change these rules for one reason or another. In fact, BIPs can lead to disagreements in communities that can lead the more conservative ones to stay with the old rules and those who do like the new changes to join a new project. If the Bitcoin blockchain were to find itself in this situation, either try to reach a middle ground where everyone is satisfied and therefore a new compromise is reached by everyone, or, eventually the split would be allowed to happen. Building consensus on what to do is one of the freedoms introduced by blockchain technology. It is the community that has the power to decide. Soft forks. Going back to the previous case, if members of the Bitcoin community were to finally reach a compromise that such an improvement proposed by us is implemented on the blockchain, users would not have to choose which version to follow of the software, as the fork would not happen, but you would only be dealing with an upgrade of the current software. A soft fork is used to introduce different network consensual changes to the Bitcoin software. These changes must always be fully compatible with previous versions, allowing the coexistence of both new and older versions without users having major problems both in their use of any version and in wanting to upgrade to the latest one. What is sought, therefore, is to change the rules established to validate the blocks. Blocks that would have been previously validated may no longer be valid under the new rules, however, those that were invalid before will also be invalid now under the new rules. For these types of updates to the Bitcoin software to occur, it is only necessary for the Bitcoin core software to be updated by the majority of miners, although it is more convenient for all members of the network to have the new version of the software so that the new rules established are the same for everyone. Although, as we have seen, this type of update is usually carried out by the miners, there is another procedure called USF, which is short for User Activated Soft Fork. This represents a mechanism in which the activation time of a soft fork on the blockchain is applied by the full nodes, which are commonly referred to as the economic majority. Traditionally, soft forks have been activated by miners, who exercise their control over the network. However, a USF mechanism takes this control from the miners and places it in the hands of the nodes. Soft forks are intended to improve blockchain operations by introducing new features. Unlike hard forks, soft forks do not split the blockchain network, as they simply implement some slight changes with the intention of improving the current blockchain, and more importantly, they do not violate any current rules of the existing protocol, whereas hard forks do. However, there may be different opinions on how and when these changes should be adopted. Usually, miners could greenlight a soft fork and set its activation time by leveraging its hash power. But sometimes the entire blockchain community might not agree with the majority of miners, and this is when a USF makes sense. Under the concept of the USF mechanism, it is the blockchain economy, including individual users, wallet providers, exchanges and other entities, that triggers the activation of the soft fork. When the economy triggers the soft fork, everyone ignores transactions and blocks that do not comply with the new rules. While miners could break the new rules if they wanted to, it is in their interest to avoid approving invalid transactions and blocks, since their block reward would be meaningless in an ecosystem that considers those blocks to be invalid. As we can see, a USF involves a great deal of coordination and the support of an entire blockchain community, and although it may seem complex to achieve, we have a clear example that it is possible with the famous BIP 148 case. Hard fork. A hard fork is, like a soft fork, an upgrade of Bitcoin software. However, the difference lies in backward compatibility.
In this case, the new versions are not backward compatible, i.e., both versions cannot coexist, and network members must upgrade if they want to continue to be able to verify and validate the blocks of the new chain.
One of the consequences of a hard fork is that all blocks that have been confirmed by a node that does not have the latest version of the software will no longer be valid. Therefore, nodes that want their blocks to continue to be verified by the forked network will have to follow the new consensus rules. The abandoned blockchain may continue to exist in case it still receives support from miners, so eventually both chains could end up existing at the same time. Hard forks can generally have two subcategories. They can be a planned hard fork or a contentious hard fork. Planned hard fork. A planned hard fork is simply an update to the protocol that had already been clarified in advance by the project developers. Usually, a high degree of consensus of the project developers and the community would have already been reached before the hard fork occurred. An example of planned hard forks would be that of cryptocurrency Monero in January 2017, which saw the addition of a new privacy feature known as Ring Confidential Transactions, Ring CT. Contentious hard fork. These types of hard fork occur when there is a serious disagreement between various stakeholders in the project, which may include project developers, network users, and miners. Contentious hard forks typically take place because one part of the community believes that major changes to a blockchain's code will produce a superior blockchain. A well-known example of a contentious hard fork was Bitcoin Cash, where it was believed by one part of the community that increasing the Bitcoin block size from 1 megabyte to 8 megabytes would allow faster processing of transactions on the network. The hard forks is a process that will certainly continue to be done in the future and with much more assiduity than so far. In fact, a blockchain must have hard forks throughout its life to remain healthy, truly decentralized and able to absorb the constant improvements generated by technological evolution. In summary, in this unit we have learned that the most basic part of a blockchain are the blocks, which shape and build a blockchain. These blocks contain different types of data and basic information to maintain and continue the structuring of the blockchain. When one of them is completed, it becomes an indivisible link and gives way to the generation of a new block. In this way, the entire network runs in a cycle and all data is stored permanently. Each block contains records of some or all recent transactions, and a reference to the block that preceded it, which, together with the point-to-point verification system, makes all transactions that are recorded in the blocks of the chain impossible for any user to change or delete. All this information contained in the blocks must be secured, for which the hash function is used to encrypt all the content. This hash function must have three basic properties. Its input can be of any size. Regardless of its input, the output will always have the same size. It must be computationally efficient, being able to calculate the output in a reasonable amount of time. Satoshi Nakamoto's major innovation was to create a new rule that was added to the existing ones. When a new set of transactions, a block, is added to the existing chain, an extremely difficult and impossible mathematical problem must be solved. This task is done by the so-called miners and consists of finding the origin that gives rise to a given hash. When the origin is finally found, a new block is added to the chain and whoever has solved the riddle receives a reward in the form of the coin being mined. Solving the problem is what is called proof of work, which is a test of how much energy was used to try to solve the problem. A public key is addresses where we can store cryptocurrencies, for example, and they need the private keys to be unlocked. Mining is usually confused with creating new bitcoins, however, the mining process is what makes the blockchain a fully decentralized system. It gives security to the system and enables it without a central authority. One must clearly differentiate the mining of the new bitcoins that are generated and delivered to the miners, from the actual process they perform. A soft fork could be defined as an update of the characteristics of a blockchain, with the new version being fully compatible with the old one. A hard work, on the other hand, is a separation of the main chain, thus creating two totally different chains that are not compatible with each other. Blockchain Course Unit Number 08, Blockchain Types. In the last decade, the blockchain has been in constant evolution, as we could see when we talked about Blockchain 2.0. Bitcoin uses what has been the first generation of the blockchain and, in turn, the first type of blockchain to exist, the public one. Today, there are different types of blockchains that have been designed for different types of purposes and that, in turn, solve different problems presented by the original blockchain. In this module we will see why there is a need for these different types, what they are and their differences. Goals. The objectives of Unit 8 and 9 are: to know the different types of blockchain and their characteristics, to know in which cases to implement each type of blockchain, to know the advantages and disadvantages of each type of blockchain, to know the term IoT or Internet of Things, what it consists of and its relationship with the blockchain. To learn about the different potential applications as well as those that IoT already has today in our society. Learn how to create a blockchain with free online tools. Types of blockchain. As we know, the first application of the blockchain was in cryptocurrencies, which not only sparked a new economic revolution, but also paved the way for a new concept called decentralized ledger technology or DLT. This new concept has given organizations a hitherto unimaginable ability to not depend on a classic or also called centralized financial entity, drastically changing the way they operate and distancing themselves from what was hitherto commonplace. It has also helped to solve all the drawbacks that derived from centralization, but, however, not all are advantages. The blockchain brings with it a series of problems that still need to be solved and, of which, the one that stands out above the rest, is how to apply this technology in different social spheres. For example, POW, the consensus algorithm that came hand in hand with Bitcoin, is inefficient because the nodes need to use large amounts of energy to solve the complex mathematical calculations for the resolution of the blocks. At the beginning, when the difficulty was low, it did not mean any problem, but as both the energy and the time needed to solve the equations went up, it increased considerably. This inefficiency makes it unsuitable for any system, more so today, where everything in our society is starting to lean towards a constant saving of energy resources. This inefficiency is just one more of the problems to be solved that come hand in hand with the first generation of the blockchain. Along with it come others such as lack of automation or lack of scalability. Now, let's approach the problem from a different perspective. Not in all cases a public blockchain can be used because, for example, that would mean making public all aspects of a company, offering all its rivals a huge amount of critical data on the operation of its business and that they could employ to use it for their own benefit or to use it against it. It is precisely for these cases that the private blockchain was created, which offers a totally private network and where the organizations themselves decide who participates in them. In this way it is possible to avoid making everything public and maintain the characteristics and benefits that the use of the blockchain brings. Now that we have understood where the need to create other blockchain comes from, let's see which are the others, besides the already mentioned private blockchain. Mainly we can find four types of blockchain: public, private, federated and hybrid. Public blockchain. This type of network is the one we have been talking about so far and, therefore, we know the most. A blockchain with the distributed ledger without permission where anyone can join and make transactions. It is a type of network that offers no restrictions and where anyone can have a copy of the ledger in their possession and therefore access the blockchain. Both proof of work, POW, and proof of stake, POS, can be used as a consensus method to verify transactions. This verification work falls to the nodes that participate in the network, and without which, therefore, the public blockchain would cease to function. Some examples of public blockchain are Bitcoin, Ethereum, Litecoin or Neo. Public blockchain advantages. A public blockchain can be joined by anyone who wishes to join. It brings trust to all the members that make up the network. It encourages everyone to participate and help to improve it. It does not require intermediaries to function. They are secure depending on the number of participating nodes. They are transparent since the data available are so for everyone, so they can be verified by anyone. Public blockchain disadvantages. Their transaction speed can be slow, having to wait, sometimes minutes or hours for the transaction to complete. Bitcoin is capable of performing 7 transactions per second, far from the 24,000 that the Visa network is capable of. This is because it takes time to solve the mathematical problems and then complete the transaction. However, possible solutions to improve this speed deficiency are already beginning to appear in the Bitcoin community, with the most promising being Lightning Network. This new improvement has the potential to bring Bitcoin to levels close to 1 million transactions per second, although it is still under development and is not without its problems. Another problem we have already discussed is scalability, which is very limited due to the way it operates, becoming slower and slower as more nodes join the network. Once again, Lightning Network may be the solution to this problem, removing from the blockchain what makes it most cumbersome, the transactions. This would help to drastically improve, not only the speed of the network, but also in scalability. The proof of work, POW, that Bitcoin uses is another disadvantage because, as we have seen above, it consumes large amounts of energy, being much more efficient than proof of stake, POS, that makes use of much more efficient algorithms. Public blockchain use cases. There are a multitude of cases in which this type of public blockchain could be applied. Let's look at a couple of examples. Voting. Countries can make use of the public blockchain to make voting much more reliable. Fundraising. Any company or organization could make use of the public blockchain to gain the trust of potential patrons. Private blockchain. A private blockchain, unlike the public ones, works in a closed environment where whoever wishes to join and participate directly in it cannot do so without the authorization or permission of the network manager. This makes the nature of the private blockchain from being decentralized to centralized due to that existing authority that controls the network. And these are the only differences between the public and private blockchain, since the rest of the functions that characterize it, such as transparency and security, remain intact. This type of blockchain is especially useful when we talk about companies or any other private entity that wants or needs to have an extremely secure and reliable working environment. By using the private blockchain, the manager also ensures the control of accessibility to it and the network configuration itself, being able to adapt it to their needs. Some examples of private blockchain are multi-chain, Hyperledger, Fabric, Hyperledger Sawtooth or Corda. Private blockchain advantages. Private blockchains are faster. The speed in a blockchain is given by the number of nodes that compose the network. These nodes have to reach a consensus, so the more nodes that compose it, the longer it will take to reach such consensus. A private blockchain is composed of few nodes and as a consequence they reach an agreement much earlier, giving the network a faster transaction speed. Private blockchains are more scalable. In this type of network only a few nodes are authorized to validate transactions. This allows new nodes to be added without reducing the speed of the network and therefore maintaining its same efficiency. Private blockchain disadvantages. The biggest disadvantage is that they are centralized blockchains, even going against the very philosophy of the blockchain. With a central authority, it is difficult to gain the trust of the other members of the network, since they will always be at the mercy of the decisions of the central authority. Although security is one of the main characteristics of the blockchain, the fact that the private networks are made up of a reduced number of nodes means that security is ostensibly reduced. This is because it would be much easier to get to take control of 51% of all of them and, therefore, take control of the entire network. Private blockchain use cases. There are multiple use cases for private blockchain: supply chain management, asset ownership and internal voting. Federated or consortium blockchain. A federated blockchain is used to solve the requirements of organizations where there is a need for public and private blockchain features, being able to choose which parts of the organization will belong to one domain or the other. Consensus in this type of blockchain is achieved thanks to a series of pre-established nodes that are specifically in charge of this function. Although it is not open to individuals, it still retains the decentralized nature. This is possible since this type of blockchain is managed by more than one organization, so no one is in control. Another feature that this type of network has with respect to the others is the existence of a validator node. This type of node performs two different functions, sending and receiving transactions and also validating them. This last characteristic, that of validation, is what distinguishes it from the rest of the member nodes of the network, since these can only send or receive transactions. Some examples of this type of network are Marco Polo, Energy Web Foundation, IBM Food Trust and Voltron. Federated or consortium blockchain advantages. They offer greater control over network resources. They are more customizable. Higher level of security and access control. They have greater scalability. They are more efficient compared to public networks. They have a well-defined organizational structure. Federated or consortium blockchain disadvantages. Despite its high security, it does not cease to depend on the members that compose it to maintain its integrity. It is less transparent. All the configurations and/or regulations that are applied can generate various problems in the network functionality. It is also less anonymous compared to other types of blockchain. Federated or consortium blockchain use cases. Banks. Consortia of banks can be created that decide which of the nodes belonging to the network will validate transactions. Research. A consortium blockchain can be used to share data and results of a research. Food tracking. Hybrid blockchain. Hybrid blockchains may appear to be the same as federated blockchains, and while they are not, they do share some characteristics. Hybrid blockchain is best defined as a combination of a public and private blockchain, and where the best features of one and the other are often chosen to make up the network. Some examples of hybrid blockchain are Dragon Chain or Fin. Hybrid blockchain advantages. In case privacy is needed, these can work without everything having to be published. They have greater scalability than public networks. Rules can be adjusted as needed. -51% attacks do not affect them. Hybrid blockchain disadvantages. It is not easy to transit to such a blockchain due to its complexity. It is not completely transparent. No incentives to participate and contribute to the network. Hybrid blockchain use cases. Real estate markets such as real estate companies can benefit from this type of network, as it would allow them to work internally and, in turn, be able to publish the information they want for their potential customers. Retail sector. They can be especially useful for this type of sector as they allow them to optimize all their processes. Heavily regulated markets. In markets such as electricity, finance or health, they can be a great step forward, allowing a high level of privacy and transparency at the same time. Blockchain Course Unit Number 09, The Internet of Things, IoT, and Blockchain. The Internet of Things, IoT, is a term recently coined to refer to the growing number of devices, which are not traditional computing devices, but are connected to the Internet with the sole function of sending the data they collect and receiving instructions, either by the owner of the device or by the manufacturer itself. In recent years, not only the number of devices has increased, but also the types. Today, there is an incredibly wide range of things that can be added to this nomenclature, such as Internet-connected smart versions of traditional household appliances like refrigerators and light bulbs, gadgets whose existence is only possible because we live in a society where the Internet has become ubiquitous, such as Alexa-style digital assistants, or different types of sensors that are radically changing all kinds of industrial and service sectors. What is the Internet of Things IoT? IoT brings the power of the Internet, data processing and analytics to the real world of physical objects. For consumers, this means interacting with the global information network without the intermediary of a keyboard and a screen. Most everyday objects and devices can come to take instructions from that network with minimal human intervention. In the enterprise setting, IoT can bring the same efficiency to physical manufacturing and distribution that the Internet has long provided for knowledge. Millions, if not billions, of embedded Internet-enabled sensors around the world provide an incredibly rich set of information that companies can use to gather data on their security of their operations, track assets, and reduce manual processes. Researchers can also use the IoT to collect data on people's preferences and behavior, although that can have serious privacy and security implications. The data collection website Priceonomics gave a series of numbers that show just how huge this sector is. There are more than 50 billion IoT devices as of 2020, and those devices will generate 4.4 zettabytes of data this year. A zettabyte is 1 trillion gigabytes. By comparison, in 2013 IoT devices generated just 100 billion gigabytes. The wealth generated by the IoT market is equally staggering, with estimates of the market's value in 2025 ranging from $1.6 trillion to $14.4 trillion. History of IoT. In the beginning, everything connected to the internet needed a processor and a means to communicate with other things, preferably wirelessly, and those factors imposed a set of costs and power requirements that made widespread IoT deployments impractical, at least until Moore's Law was achieved in the mid-2000s as far as transistor size reduction was concerned. A major milestone was the widespread adoption of RFID tags, inexpensive minimalist transponders that could be installed in any object to connect it to the larger internet world. With the advent of 4G and the massive presence of Wi-Fi device designers and programmers simply assumed that wireless connectivity would be present everywhere. Eventually, the implementation of IPv6 meant that connecting billions of gadgets to the internet would not exhaust the number of available IP addresses, which was beginning to be a very real problem known to few. How does the IoT work? The basic elements of the IoT are devices that collect data. Broadly speaking, they are devices connected to the internet, so each has an IP address. They range from autonomous vehicles that transport products around a factory to simple sensors that monitor the temperature in buildings. They also include personal devices such as smartwatches that monitor the number of steps we take per day or how we have slept. For such data to be useful, it needs to be collected, processed, filtered and analyzed, each of which can be handled in different ways. The data is collected by transmitting it from the devices to a collection point, which are usually servers of the company that owns the device or program, or, on the other hand, it is collected in a cloud. They can be transmitted both wirelessly and over wired networks. As we say, data processing can take place in data centers or in the cloud, but sometimes it is not an option. In the case of critical devices such as, for example, power outages in industrial environments, the delay in sending data from the device to a remote data center is too great. The round-trip time to send data, process it, analyze it, and return instructions, close that valve before the pipes burst, may take too long. In such cases, perimeter computing can come into play, where a smart device can aggregate data, analyze it and create responses, if necessary. All within a relatively close physical distance, thus reducing delay. These perimeter devices also allow them to be connected so that they can send data to be processed and stored. Examples of IoT devices. Essentially, anything that is capable of collecting information about the physical world and sending it back home can participate in the IoT ecosystem. Smart home appliances, RFID tags and industrial sensors are a few examples. These sensors can monitor a range of factors including temperature and pressure in industrial systems, the status of critical parts in machinery, patient vital signs, and water and electricity usage, among many other possibilities. Factory robots can be considered IoT devices, as can autonomous vehicles that move products around industrial environments and warehouses. Other examples include fitness wearables and home security systems. There are also more generic devices, such as Raspberry Pi or Arduino, that allow you to create your own IoT endpoints. IoT device management. To work together, all of these devices need to be authenticated, provisioned, configured, and monitored, as well as patched and updated as needed. Too often, all of this happens in the context of a single vendor's proprietary systems, or never happens at all, which is even more dangerous. But the industry is starting to move to a standards-based device management model, which allows IoT devices to interoperate and will ensure that devices are not orphaned. A clear example of the latter is where the motor industry is heading, where all brands are racing to be the first to achieve true autonomous driving, where the passenger does not have to interact with the vehicle. To achieve this, it is necessary, among other things, that the vehicles are able to communicate with each other, warning of any accident, road section cut or even if the road is in bad condition for any reason. In this way, a safer and much more efficient circulation would be achieved, since the vehicles themselves would be able to act in advance of what is happening in the sections through which they plan to pass thanks to the interconnection between all of them. When IoT gadgets communicate with other devices, they can use a wide variety of communication standards and protocols, many tailored to devices with limited processing capabilities or not much electrical power. Some of these devices use Wi-Fi or Bluetooth, for example, but many others are specialized for the IoT world. Zigbee, for example, is a wireless protocol for low power, short distance communication, while MQTT, message queuing telemetry transport, is a protocol for devices connected over unreliable or delay-prone networks. The increased speeds and bandwidth of the upcoming 5G standard for mobile networks will also benefit IoT, although such usage will lag behind ordinary cell phones. For many IoT systems, there is a lot of data coming at them quickly and constantly, which has given rise to a new category of technology, edge computing, which consists of devices placed relatively close to IoT devices in a radius where they reach the data stream sent by the devices themselves. These machines process that data and send only relevant material to a more centralized system for analysis. For example, imagine a network of dozens of IoT security cameras. Instead of bombarding the building's Security Operations Center, SOC, with simultaneous live streams, perimeter computing systems could analyze the incoming video and only alert the SOC when one of the cameras detects motion. This data could go to a centralized data center, but most of the time it ends up in the cloud. The elastic nature of cloud computing is ideal for IoT scenarios where data can come in intermittently or asynchronously. In fact, cloud service giants such as Google, Microsoft and Amazon have IoT offerings in their portfolio. These giants are trying to sell more than just a place to store the data that a series of sensors have collected. They offer complete IoT platforms, which bring together much of the functionality to coordinate the elements that make up IoT systems. In essence, an IoT platform serves as an intermediary that connects IoT devices and perimeter gateways to the applications that are used to process IoT data. IoT and data. As we have already discussed, there are zettabytes of data being collected between all these IoT devices, funneled through perimeter gateways, and sent to a platform for processing. In many cases, this data is the reason IoT was implemented in the first place. By collecting sensor information in the real world, organizations can make agile decisions in real time. Oracle, for example, posits a scenario in which people at a theme park are encouraged to download an app that provides information about the park. At the same time, the app sends GPS pings back to park management to help predict wait times in lines. With that information, the park can take action in the short term, adding more staff to increase capacity on some rides, for example, and in the long term, learning which rides are the most and least popular in the park. These decisions can be made without human intervention. For example, data collected from pressure sensors in a chemical factory pipeline could be analyzed by software in an edge device that detects the threat of a pipeline rupture, and that information can trigger a signal to close valves to prevent a leak. IoT and big data analytics. Many big data operations use information extracted from IoT devices, correlated with other data points, to gain insights into human behavior. A dramatic example was when Xmode published a map based on tracking the location data of people who spent their spring break in Ft. Lauderdale, Florida, USA, in March 2020, even as the coronavirus pandemic was gaining speed in the United States. The publication of the map showing where all those people had ended up was shocking, not only because it showed the potential spread of the virus, but also because it illustrated the extent to which IoT devices can track us. IoT and AI data. The volume of data that IoT devices can collect is far greater than any human being can do, and it wouldn't even do it in real time. We have already seen that edge computing devices are needed just to make sense of the raw data coming from IoT connection points. However, there is also the need to deal with and detect among all that huge amount of information which ones are erroneous. Many IoT vendors offer machine learning and artificial intelligence capabilities to try to make sense of all the data collected. One example is IBM's Watson platform, which can be trained by feeding it IoT datasets to produce useful results in the field of predictive maintenance, analyzing drone data to distinguish between trivial damage to a bridge and cracks that show imminent danger and need quick attention, for example. IoT and business. Business uses for IoT include keeping track of customers, inventory, and the status of important components. IoT for all marks 4 industries that have been transformed by IoT. Oil and gas. Isolated drilling sites can be better monitored with IoT sensors than by human intervention. Agriculture, data extracted from IoT sensors installed on crops can be used to increase field yields. HVAC, heating, ventilation and air conditioning. HVAC systems can be managed remotely and much more efficiently. Physical stores, customers can be informed about particular offers on their phones depending on which area of the store they are in or whether they have visited one area more than another. More broadly, companies are looking for IoT solutions that can help them in 4 areas: energy usage, asset tracking, security, and customer experience. The IoT is a specific subset of the Internet of Things comprised of connected sensors and instrumentation for machinery in the transportation, energy and industrial sectors. The IoT includes some of the most established sectors of the IoT market, including descendants of some devices that predate the IoT moniker. IoT devices are typically longer lived than most IoT connection points, some remain in service for a decade or more, and, as a result, may use legacy and proprietary protocols and standards that make it difficult to move to modern platforms. Consumer IoT. The move of IoT devices into consumer spaces is more recent, but much more visible to everyday people. Connected devices range from wearable devices that track our movements to internet-enabled thermometers. Probably the most prominent IoT product category is home assistants, such as Amazon Alexa or Google Home. IoT and smart cities. Smart cities promise to transform the way we citizens interact with the urban environment. Smart city technology is still embryonic, but in theory it will help manage traffic, public transportation, utilities, security and more. However, because the information that would be recorded would be highly sensitive, security improvements become a pressing need before widespread adoption is possible. Security and vulnerabilities. IoT devices have earned a bad reputation when it comes to security. PCs and smartphones are general-purpose computers designed to last for years, with complex, easy-to-use operating systems that now have automated patching and security features built in. IoT devices, by contrast, are mostly basic gadgets with simple operating systems. They are designed for single tasks and minimal human interaction, and many cannot be patched, monitored or updated. Because many IoT devices are ultimately running a version of Linux under the hood with multiple network ports available, they become tempting targets for hackers. The biggest example of this was the Mirai botnet that infected around 380,000 devices in 164 countries in 2016 by exploiting the fact that many of them were still using the factory default username and password and ended up launching one of the largest DDoS attacks in history. It is precisely at this point of vulnerabilities where the blockchain enters the scene to create a link with IoT that will solve most of the problems we mentioned a moment ago. The combination of IoT and blockchain offers several potential benefits and allows a smart device to operate autonomously without requiring the presence of a centralized authority. It can also keep track of how devices communicate with each other. While the decentralized nature of blockchain is an architectural benefit, it can also become a potential problem for IoT. IoT platforms rely on client-server architecture, which is a centralized authority. Creating an IoT platform that is decentralized in nature will help ensure compatibility with a blockchain network, but it can become quite complex to configure IoT sensors to handle their own data storage and operations, as they rely on the operational and storage resources of a central unit. Blockchain has been implemented with IoT across industries, including banking, financial services, automotive, and agriculture. It has also been used with IoT in smart homes, supply chains, logistics, and in the well-known smart contracts. The latter apply blockchain to IoT ecosystems to automatically execute a contract once certain conditions are met. This is what allows a smart device to operate on its own without the need for a centralized authority. This application of blockchain technology allows companies to manage data on perimeter devices in an IoT system, reducing the costs associated with maintaining and transferring data from IoT devices. It reduces the risks of managing data, because there is no centralized repository where it all accumulates and the ledger is not vulnerable to cyber attacks. It eliminates the IoT gateway or any other intermediate device for data exchange and reduces the time needed to process the data. Blockchain gives the IoT system a high level of security that it did not have until now through the familiar features of data encryption and decentralized data distribution. As a result, the failure of one device, server or network will not affect the entire IoT ecosystem, as might happen in the traditional model. In many cases, the resiliency of a blockchain network would do error control, where the network can continue to function if nodes go offline. The Mirai botnet already exposed the vulnerabilities of connected devices to DDoS attacks due to the weak access controls and client-server structure of IoT networks. But these can be protected against such botnet-based DDoS attacks with the distributed security architecture of a blockchain as, in this architecture, each device in a network is independently protected with a peer-to-peer blockchain network. IoT blockchain technology is now in its early stages, and some of the leading technology companies have started to look for opportunities in this space. For example, IBM Blockchain Platform enables companies to extend blockchain to cognitive IoT, a set of technologies that combines IoT and cognitive computing. IoT blockchain technology is slowly starting to become mainstream, although some operational and technical issues remain to be solved. We already know that scalability and storage are major issues in blockchain systems that in many cases have to maintain a huge centralized ledger which would have to be stored on perimeter nodes, and this is certainly hugely inefficient, as smart devices at the edge are not yet capable of storing large volumes of data or handling relatively large amounts of computing power. This certainly presents a challenge, but with the continued improvement of blockchain and the creation of other types of blockchain concepts, these scalability and storage issues may soon be a thing of the past, likely having a massive impact in the coming years. The implementation of standard security rules and regulations will encourage the adoption of IoT blockchain technology. By introducing new standards for data transparency and peer-to-peer communication, blockchain can add a new degree of security to the Internet. Blockchain Course Unit Number 10. How to create our own cryptocurrency and blockchain. Creating a blockchain from scratch is not exactly an easy task. There are different methods to do it, but all of them require a high degree of knowledge of certain programming languages, tools, and even operating systems that are not very widespread among users, such as Linux. Fortunately, there are other much more affordable alternatives that allow people who are starting in this world of blockchain to put into practice much of the existing literature on this subject. As we know, cryptocurrencies use the blockchain as the basis for all their functions, and many of them have released their code, so we can use it to create our own currency and, therefore, have our own blockchain. This in itself is not easy either, and we would still need quite a lot of programming knowledge to be able to modify the code at our whim and finally make it functional. However, in recent years there have appeared platforms that do this work for us through simple steps. This is the case of the wallet builders. Com platform, which we will use to create our own cryptocurrency in a very simple and totally free way. Step 1. Create your own cryptocurrency and blockchain. First, we must access the website https://www.walletbuilders.com/. Once inside, we will see the main page which has two buttons: Get Started and Learn More. The second button will take us to the section where we are given some explanations about the purpose of the website and the different working tests that we can choose for our future cryptocurrency. We will click on the first button that told us Get Started. Step 2. Create your own cryptocurrency and blockchain. Once we click the first button, the website will send us to the tutorial for the creation of our coin. The tutorial will be positioned by default in Step 1, called Your Coin. Let's see what fields appear in each step and what their function is. Email address, we place our email address which will be needed later. Coin type, we can select if we want it to be paid or free. We leave it in the free option. Coin algorithm, in this last field we can choose what type of algorithm our coin will be based on. For this tutorial, we will leave it default to the script, POW, option and click at the bottom right on the yellow button where it says Next. Step 3, create your own cryptocurrency and blockchain. Coin name, here we will put the name we want our coin to have, for example, Blockchain Stop. Coin abbreviation, in this field we put the abbreviation of our coin, for example, BSTOP. Address letter, we put a number or a letter with which we want the public addresses to begin, for example, the letter B. Verbal timestamp, we write a phrase that will be linked to the Genesis block, for example, sample. The next two fields, website URL and GitHub URL, are used to put informative links about our currency, and we click on Next. Step 4, create your own cryptocurrency and blockchain. Block reward, the amount of coins the miners will receive in the proof of work, we will put 100. Block halving, this field refers to the number of blocks that must be in the chain before halving. We put, for example, 50,000. Coin supply, this field is automatically filled in taking into account the data entered for the mining reward and the blocks needed for halving. Click on the Next button. Step 5, create your own cryptocurrency and blockchain. Coinbase maturity, we put the number of blocks we want to pass before the coins can be spent. Number of confirmations, field to set the number of blocks needed for a transaction to be confirmed. Target spacing in minutes, time in minutes that it should take to mine a block. Target time span in minutes, maximum mining time in minutes until which the difficulty will not be adjusted. Node 1 and Node 2. This option would be useful to put the address of a node that we have created. However, for this tutorial we will use the ones that the same platform provides us for a while, so we leave it the same as this one and press Next. Step 6, create your own cryptocurrency and blockchain. In this step we get a message that tells us that we have selected a free currency, so it does not allow us to upload our own logo, which is not important for the tutorial. We click on the Purchase button. Step 7, create your own cryptocurrency and blockchain. Once we hit the Purchase button, a message will appear informing us that they have sent us an email with the necessary information to be able to enter the management menu of our cryptocurrency. Step 8. Create your own cryptocurrency and blockchain. In the email we receive, our coin will appear, which is what we will need to be able to log in to the platform. Step 9. Create your own cryptocurrency and blockchain. Once we click on the login option on the web, a box will appear where we will have to enter the coin that we were sent to our email. Step 10. Create your own cryptocurrency and blockchain. Finally, we will press the login button and our management menu will appear, in which we will be warned that our currency is being created and that we will have to wait a number of minutes. These minutes may vary depending on the configuration we have chosen and the workload of the platform. When the process of creating our coin is finished, we will be able to see all its features in the menu. In this menu we will also find two of the most interesting options. The first one is the possibility to download our own wallet for both Windows and Linux. Secondly, we will be able to mine our own coins following the indications shown in the Getting Started menu option. As you can see, following this procedure, it is not difficult to create our own fully operational cryptocurrency with which we can experiment and familiarize ourselves with the functioning of a wallet, mining, and finally with the blockchain itself. Blockchain Course Unit Number 11. Cryptocurrency Blockchain Applications. In the previous units we have seen in depth the parts that make up a blockchain and its operation, as well as the special features it possesses, providing it with unique qualities that are already beginning to be used by many companies in different sectors. Cryptocurrency. Throughout the course we have been using Bitcoin as an example to explain many of the functions and mechanisms of the blockchain, so we already have more or less an idea of what a cryptocurrency is. However, at this point, we will try to delve even deeper into this sector to get a broader perspective of the idea behind this economic revolution. A cryptocurrency can be defined as a digital medium to which a certain value is assigned and which can be used as an exchange. These types of currencies use cryptography to validate and protect all their transactions. Cryptocurrencies that have a real equivalent value, or that can be used as a real currency, are known as convertible, with Bitcoin being the most obvious case of a convertible currency. The financial crisis as a trigger for cryptocurrency's birth. The money we use today, fiat currency, is issued as legal tender by our governments and is controlled by them and the banks that manage its supply, issuance and distribution. It is usually good enough for us to use on a daily basis, as long as we trust the governments and the banks. Throughout history, and even today, we have seen examples of governments hyper-inflating their currency, or banks withholding money from families to avoid losses in the millions. In addition to this type of act, it can also be very inefficient, for example, when banks do not make an urgent international transfer during weekends because they do not operate during that period. It was just after the financial crisis of 2007-2008, when Satoshi Nakamoto created Bitcoin, which he described as a point-to-point electronic cash system. The first block in the Bitcoin blockchain included a message. The Times, January 3, 2009. Chancellor on brink of second bailout for banks. The creation of Bitcoin was probably intended to strike a blow to the current banking system. After the effects of the financial crisis, many banks were unable to stay afloat and had to rely on government bailouts to survive, using taxpayers' money, which was all the more galling for many as they themselves had caused the crisis. Many of the original supporters of cryptocurrencies were very much against the way in which governments engage in printing money to try to save the economy, due to the fact that, in doing so, they were devaluing the money that people had and in turn, were putting control in the hands of politicians. With the birth of Bitcoin, many began to see a new path to a world where people were in control of their own money. To all this, we must add the rise of news, where it was reported that large internet companies were selling their users' data for huge profits, so we began to have the initial ingredients of a revolution where idealists were already imagining a world in which citizens were sovereign individuals, people who had total influence over our money and our privacy. From this point the idea gradually spread. Main characteristics of cryptocurrencies. Let's look at some advantages and solutions that cryptocurrencies may be able to provide through their decentralized nature. Eliminate money printing. Governments have central banks, and central banks have the ability to print money when faced with a serious economic problem, as happened in 2008. This process is also called quantitative easing. By printing more money, a government may be able to bail out debt or devalue its currency. However, this approach is considered by many economists as putting a band-aid on a broken arm. Not only does it rarely solve the problem, but the negative side effects can also sometimes outweigh the original problem. For example, when a country like Iran or Venezuela prints too much money, the value of their currency drops so much that inflation skyrockets and people can't even afford to buy everyday goods and services, their money loses all value. Most cryptocurrencies have a limited and fixed amount of coins available. When all those coins are in circulation, a central entity or the company behind the blockchain has no easy way to create more coins or add to the existing supply. They give people control over their own money. With traditional money, people deposit all their control to central banks and the government. These, in certain circumstances, can freeze accounts and deny access to funds. Some governments can even abolish legal tender bills, as India did in 2016. With cryptocurrencies, the only people who have access to the funds are the people who have the private keys to the wallets. Elimination of third parties. One of the goals of cryptocurrencies and blockchain technology is to try to create a much more efficient and faster asset transfer system than we have now. Currently, when we swipe our credit card when we buy something, there can be several intermediaries that are part of the transaction. These exist to ensure that we have the ability to make the payment and the merchant has the ability to accept the payment. However, that verification process comes at a cost to merchants in the form of credit card payment processing fees. Low transaction fees. Related to the previous point, the mere fact of removing a third party from the transaction equation helps fees to be drastically reduced, with many cases being able to be zero. However, not all cryptocurrencies have zero transaction costs due to different reasons, although, either way, they are still much lower fees than what we find in the methods currently available for traditional money. Helps people without access to means of payment. A large part of the world's citizens do not have access to payment systems such as banks. Cryptocurrencies aim to solve this problem by spreading digital commerce around the world so that anyone with a cell phone can have the option to make payments. Transactions are irreversible. Once a transaction is confirmed, it cannot be reversed by anyone in the full spectrum of its meaning. There is no going back. This has a positive but also a negative side, since, if we send our money to the wrong address, we depend on the goodwill of the recipient to return the funds. Only pseudonyms are used, the identities of the users making the transactions or holding the accounts are not linked. The most that can be achieved is to analyze the flow of transactions, although this does not necessarily mean that it is possible to connect the real identity of the users with the addresses they have. Fast and borderless, transactions are made almost instantaneously and are confirmed in a matter of minutes. Because the network is composed of a global network of computers that are located in different parts of the world, it does not matter from where the transaction is made, whether to a person living in your neighborhood or to someone on the other side of the planet. Security. All funds available in the wallet are encrypted in a public key system, so only the person who has the private key can unlock the account. As we have already seen, this feature makes it almost impossible to break this security scheme. No authorization required. You do not have to ask for permission or receive any authorization from any administration or entity in order to use cryptocurrencies. You only need to download and install a free software. Once installed, you can receive and send the cryptocurrency in question instantly without anyone being able to prevent or control it. Anytime, transactions can be made at any time without depending on schedules, holidays or any other event that may delay our transaction both at the origin and at the destination. Exchanges. Exchanges or cryptocurrency exchanges are online platforms where we can buy cryptocurrencies or exchange them with each other. They would be the equivalent of the classic stock exchange or currency exchange centers, for example. Within these exchanges there are different types depending on a series of characteristics. 1. Traditional exchanges. This type of exchange works in a very similar way to the stock exchanges we know, where cryptocurrencies are traded according to their prices. Normally, in these exchanges a commission is charged for each transaction that takes place. In some exchanges only cryptocurrency exchange is allowed, however, there are others where you can make use of fiat currency such as the euro, dollar or Chinese yuan, to buy cryptocurrencies. Some examples are Binance, Kraken, DAX, Bitfinex or Poloniex. These types of exchanges can be centralized or decentralized. In the former, there is an intermediary who is in charge of both supporting all customers by solving any problems they may have and maintaining the proper functioning of the entire platform. In the latter, called DEXs, on the other hand, there is no intermediary and their trading is based on smart contracts. Another big difference is that decentralized exchanges do not require as much information from the user as centralized exchanges do, since the latter allow trading with fiat currencies. 2. Cryptocurrency brokers. These exchanges are usually based on websites that serve the function of currency exchange sites at an airport. In this case, it is a broker who sets a price for the cryptocurrencies to which he adds a commission. The exchange is not between buyer and seller, but between a buyer or seller and the broker. Coinbase, Cash App or Shapeshift are examples of this type of exchange. It is usually the simplest solution for new users. Due to commissions and the fact that it is the broker itself who sets the price, a slightly higher price is usually paid for exchanges. 3. Direct trading platforms. These platforms offer direct point-to-point trading between buyers and sellers. Direct trading platforms do not use a fixed market price. In this case, it is the users themselves who set their buying and selling prices. The platform only serves as a channel for the meeting between sellers and buyers. There are exchanges of this type that are intended for very large buyers and sellers and others for average buyers or sellers, although logically, most customers are in the second type. Many decentralized exchanges belong to this type. This type of exchange may be the only solution in some regions, however, due to the lack of reliable measures such as smart contracts used by DEXs, it is necessary to perform a series of studies as exhaustive as possible on whether the platform is trustworthy or not. This is the most important measure to take, but not the only one. It is also advisable to check, with the help of other users' ratings, whether the person with whom we are going to carry out the transaction is trustworthy or not. Finally, we can use tools such as CoinMarketCap.com to make sure that the price, both for buying and selling, is within the market. An example of a decentralized peer-to-peer direct trading platform is AirSwap.io. Here DEX facilitates direct exchanges between users through smart contracts and therefore may not require information. Another example of a peer-to-peer exchange, this time centralized, that facilitates fiat and crypto exchanges is local bitcoins.com. 4. Cryptocurrency funds. These funds are made up of a certain amount of cryptocurrencies and which are managed and administered by professionals, allowing us to buy and hold them in such funds. An example of these funds is GBTC. This type of fund allows us to invest in cryptocurrencies without having to buy or store them directly. In a fund you cannot use cryptos as money, they only have a strictly investment use. The altcoins. Today, there are thousands of cryptocurrencies and many of them were inspired by or even directly extracted from the Bitcoin code. Collectively, these descendants of Bitcoins are known as altcoins or alternative cryptocurrencies. While some cryptocurrencies promote improved features with respect to Bitcoin, speed, security and privacy, others were created for simple fun and entertainment, such as Dogecoin. Others, however, were created with other intentions that are not so fun, seeking to deceive buyers by making them lose part or all of their investments. Within these altcoins, there are some that do have the backing of the community and with a series of characteristics that place them as a fundamental part of the crypto world. Let's take a look at some of them. Ether, ETH. In the cryptocurrency market, the Ethereum network with its Ether coin is the first among other Bitcoin alternatives. As we saw, it is a digital platform that operates through a decentralized system for the execution of smart contracts. Ether ranks second in the list of digital currencies. It was launched in 2015 and allows developers to design decentralized software and applications within the blockchain network. Ripple, XRP. It was launched in 2012. It is intended to enable payments immediately and at very low cost, $0.0004, worldwide. This type of promoted usage has made it particularly relevant for banks looking to settle cross-border transactions using the Ripple network. Unlike Bitcoin, XRP does not require mining, so there are many in the crypto community who debate whether XRP can qualify as a cryptocurrency. Litecoin, LTC. Founded by Charles Lee in 2011, Litecoin is very similar to Bitcoin and was created with the intention of improving upon it. Where Bitcoin processes one block every 10 minutes, Litecoin processes one block every 2.5 minutes, allowing for faster transaction confirmation. The Litecoin system also uses a different proof of work, POW, system than Bitcoin. It uses Script POW, a system that prevents the use of specialized ASIC chips, in order to allow more people to be Litecoin miners. Monero, XMR. Monero is one of the most secure and private cryptocurrency networks that was created in 2014. This open-source virtual currency has been created and driven by a crypto community to provide a single digital currency network. Privacy in the network is possible due to a technique called ring signatures. This allows users to remain secure and anonymous from any third party, offering advanced technology to the digital currency market. Binance Coin, BNB. It was founded in 2017 and has quickly gained popularity for its versatility in the cryptocurrency market. It is a token used for many purposes on the Binance platform, which offers an exchange platform where different cryptocurrencies can be traded. This token can also be used for payments for different goods and services. Because it is an exchange platform with unique features, it has become the largest exchange in the world. EOS. It was launched in 2017 as an ERC-20 token based on the Ethereum blockchain. A year later it became the native currency of the blockchain platform called EOS.io and is also known as Ethereum Killer. It is designed to be a very easy way in which developers can create decentralized applications. What this means is that without the need for a lot of code, an application can be created easily, and that is the revolutionary thing behind the EOS platform. Unlike Ethereum, transactions just for validation on EOS have no cost. Bitcoin Cash, BCH. Bitcoin Cash is a hard fork of Bitcoin and was created in August 2017 after the community debated for almost a year. The fork was created because a certain group of developers wanted to increase the block size of Bitcoin. They also defined that anyone holding Bitcoins would get the same amount of coins from the forked chain. In other terms, Bitcoin Cash is an upgraded version of the Bitcoin Core software. It is faster, cheaper and more secure to use. It is suitable for small and large amounts of transactions. In addition, Bitcoin Cash transactions are faster than the original Bitcoin Core, having, also, more transaction capacity. Tether, USDT. This is a stablecoin. A stablecoin is a cryptocurrency which is linked to a legal tender such as the euro or the dollar. These are issued by centralized companies that keep them stable, either by putting a guarantee or through some kind of algorithm that manipulates the supply of the stablecoin, depending on the demand. These types of stable currencies allow exchanges to create fiat currency pairs without actually accepting fiat. For example, you can have a BTC/USDT trading pair that simulates the BTC/USD market without the need for regulation. As of today, Tether supports 4 different currencies: the US dollar, USDT, Chinese yuan, CNHT, and euro, EURT, as well as a stablecoin backed by an ounce of gold, XAUT. First launched with USDT in 2014, Tether Limited, the company's idea was to make government money more compatible with newer crypto assets, which trade 24/7 in an active global market. Each USDT token is redeemable for its corresponding US dollar held in custody by Tether Limited. The total value of all USDTs is said to equal the reserves held by the company. Once a USDT is newly minted and issued, it can be transferred, stored and spent by a variety of businesses, exchanges, wallets, financial services, and individual traders looking to avoid the sometimes extreme volatility of cryptocurrency markets. These are just a small representation of a large number of other cryptocurrencies also with renown within the crypto world, such as Cardano, ADA, Tron, TRX, Stellar, XLM, Theta, or Chainlink, Link. New coins are constantly being added to the list of altcoins, but they rarely have much relevance or bring anything new to the table. However, in June 2019, Facebook announced the creation of Libra, a cryptocurrency proposed to allow users to send and receive money through the social network with the support of more than 100 companies and which would be available in 2020. Undoubtedly, if it ends up being launched, it would become one of the most influential and widely supported of all existing cryptocurrencies. Blockchain Course Unit Number 12, Financial Services Blockchain Applications. Professionals within the financial services industry have long been analyzing and studying the potential of blockchain, waiting to see how this emerging technology will change the dynamics of their business. According to a 2019 survey conducted by IBM, 91% of banks are investing in blockchain solutions, and 66% of institutions expect to introduce blockchain into many of their daily operations. These data seem to show us that blockchain is about to radically change the financial markets in a way that will benefit both consumers and financial institutions. It is easy to see how blockchain's properties make it ideal for financial applications. Blockchain facilitates secure and easy transactions and builds trust between trading partners. It can even be used to quickly identify individuals through digital IDs. Banks and other financial institutions are already using blockchain to optimize their services, reduce fraud and reduce fees for customers. Let's look at some examples. International payments. Sending or receiving money to or from other countries, or between two different national currencies, has typically been a process fraught with complexities and high costs. When electronic payment providers first emerged alongside the e-commerce giants, it was a revolution in the way customers could send money online. Typically, international payments were executed in less than a day, as opposed to days or weeks for traditional bank transfers. However, the Bank for International Settlements recently concluded that, despite innovations in the services provided to customers to make international payments, the industry was still plagued by technical hurdles and high costs. Despite this, the same entity resolved, bank transfers remained one of the preferred methods for making cross-border transactions. Financial service providers could take advantage of payment gateways created with blockchain technology to enable instant transactions 24 hours a day, with low fees regardless of the value of the transaction. In particular, stablecoins would be a type of currency that, due to their characteristics, would help make the process of transferring value across borders a simple, fast and cheap process. Digital identities. Despite the fact that financial service providers have been working on preventing it for many years, identity theft remains a growing problem. Not only does identity-based fraud have serious economic consequences, with losses of more than $40 billion in the U.S. in the last 2 years alone, but it also affects the user experience, as users have to go through lengthy and tedious KYC, Know Your Customer, and AML, anti-money laundering, processes. Instead, blockchain-based digital identities, protected through privacy-preserving technologies such as zero-knowledge proofs, serve as a single source of identity and verification data for seamless onboarding of new customers, while meeting the necessary data protection requirements. Tokenization. A token can be defined in a basic way as a unit of value issued by an organization. Tokenization of securities, such as equity, is perhaps one of the most powerful use cases for blockchain technology. Stock records are particularly ripe for digitization, and distributed ledgers would allow companies to easily issue stock-based tokens, track shareholders and update stock records without maintaining a capitalization table or having to go to enormous efforts to organize capital. By streamlining the equity issuance process using blockchain technology, companies can save time and resources, especially useful for small and medium-sized companies with limited staff. The broader benefits of tokenization for trading capital and other assets are enormous. For the first time in history, tokenized assets can be transferred anywhere in the world in minutes through blockchain-based exchanges and marketplaces, a process that would normally take days to resolve, involving multiple intermediaries and complex internal processes. Instead, blockchain-enabled exchanges and marketplaces automate the trading, execution and settlement process. As a result, trading is no longer constrained by time zones, paving the way for 24/7 trading with instant settlement times and low fees due to disintermediation. Trade finance, credit and loans. Loan financing is the most important source of external funding for most companies. However, the actual process for both lender and borrower is lengthy, generating a rather extensive paper trail along the way. This is further accentuated if companies have multiple financial providers, as each party would have different databases and companies would have to manage everything individually with each provider. To solve this, blockchain technology and smart contracts could be implemented to serve as the underlying infrastructure for trade finance agreements, automating and processing loans according to predefined criteria, and onboarding new trade finance customers through existing digital identities. The result would be a trade finance ecosystem in which any transaction or paperwork could be completed in a matter of minutes, loan contracts would require less third-party oversight, and smart contracts would legally enforce agreements. Similar efficiencies could be introduced in consumer lending via blockchain. Like incorporating a company through digital identities, banks and lenders could easily create risk profiles for retail customers through pre-aggregated information stored on a blockchain, make lending decisions instantly, decrease loan defaults and improve the customer experience. A very recent example of how the traditional financial system is progressively assuming the blockchain and more specifically cryptocurrencies, is the case of BBVA that by January 2021 will launch a service for buying and selling digital assets. In an article published on the bank's website announcing the launch of this service, the head of strategy at Client Solutions, Alicia Pertusa, spoke of the great potential of this technology in the sector. Digital assets have great potential to transform the way in which value and information is exchanged through blockchain technology. Financial institutions, in collaboration with supervisors, can play a relevant role in integrating digital assets into today's markets and infrastructures. The future of blockchain and finance. The solutions that blockchain brings to the financial sector are many, and adoption by financial service providers is only increasing. There are a multitude of them already experimenting with blockchain, developing blockchain-based MVPs, minimum viable product, running pilots and leveraging external blockchain solutions. However, for the blockchain era change to happen in this sector, there needs to be major changes in the current regulatory frameworks fully accepting and recognizing this technology and its products, which in turn will enable business decision makers to integrate blockchain into their core processes. In the future, financial service providers will most likely need to pivot their business models to include decentralized assets and value transfer, which will make autonomy, low fees, digital identities and instant transactions the norm. Blockchain Course Unit Number 13, Blockchain in Healthcare. The relationship between blockchain and the healthcare sector is a relationship that can and in many cases already does bring very positive things for the healthcare sector itself and, therefore, directly for people. One of the first things in which the blockchain can help the health sector is to solve the serious problem it suffers in the form of security breaches, where, on a daily basis, suffer continuous theft of private patient information, which in itself is serious, but to which must be added the sensitivity of the stolen data. The importance of blockchain in this sector is such that 40% of senior executives working in the healthcare sector see blockchain as one of the top 5 priorities. Proof of this is that according to a report by BIS Research, it is estimated that by 2025 the value of investment made in blockchain technology in this sector will exceed $5 billion. This huge investment may seem like a lot, however, if we take into account that the savings that the use of blockchain can bring to this industry can be between 100 and 150 billion for that same year, the perspective changes. The savings come from the drastic decrease in costs related to operations, breach of private data, personnel and support functions, as well as a radical reduction in fraud and counterfeit products. Pharmaceuticals and drugs. The pharmaceutical sector is another one that blockchain technology can revolutionize as a whole, as well as the process of drug discovery, development and distribution. Previously, it is estimated that 9 out of 10 new drugs do not make it to a clinical trial. Moreover, they do not even reach the approval stage by regulatory agencies. The big problem for pharmaceutical companies is obtaining crucial patient data at a time when people are increasingly aware of the importance of their personal data. Big Pharma, or also called Big Pharma, faces many data-related problems. These include 1. Pharmaceutical data disparity. Perhaps the most troubling data problem facing pharmaceutical companies, especially when it comes to drug development, is a serious data disparity. Keep in mind that pharmaceutical data is often recorded and hidden in silos, having access to it only through several different platforms. Add to all this that each department often uses a separate data structure and model, so having access to all the crucial data by pharma companies for big data analysis becomes extremely complicated. This is an area where artificial intelligence, big data analytics and blockchain can work together to deliver efficiency and accurate results for pharmaceutical companies. For this reason, around 61% of pharma companies are already adopting AI, with blockchain implementation in the pipeline. 2. The large consumption in time and resources required for data analytics. Considering that pharma companies have to deal with so many data sources, they clearly have a problem when it comes to collecting data, managing it, and ultimately analyzing it. The first problem they encounter is that, in the first phase of data collection, a lot of data that may prove to be crucial does not end up being collected and therefore the final analyze is not as effective as they could be. As if that wasn't bad enough, the whole process of harmonizing data from different sources can end up being quite slow. In addition, the lengthy analysis process may not uncover information that could be useful to the business. That said, it is obvious that the entire data management process for pharmaceutical companies needs to change. After all, managing large data sets is already challenging for small and large pharmaceutical companies. 3. Data inaccuracies and ambiguity around relevance. In the pharmaceutical space, there is always ambiguity around the accuracy of the available data. Is the data analytics report accurate and, if so, are the insights still relevant? Since, as we mentioned earlier, pharma companies store data in silos that can be accessed through disparate channels, so it is often difficult for them to be sure if all available data is still valid and recent. If implemented correctly, blockchain can help record, store and sort pharmaceutical data so that it always displays relevant and unambiguous information. In addition, any solution that can help pharmacists accurately manage data will be reflected in substantial financial savings, increase the bottom line and improve health outcomes for all. Let's look more specifically at how blockchain, along with other technologies such as AI, artificial intelligence, and big data, can transform the pharmaceutical industry. Improving the drug supply chain. Managing a healthcare-related supply chain carries additional risk and complexity for large pharma, as a compromised supply chain can have serious ramifications, especially on health outcomes and patient safety. In a report by BIS Research titled Global Blockchain and Healthcare Market Analysis and Forecast, 2017 to 2025, they said the following. The most prominent beneficiaries of the technology will be pharmaceutical companies, which lose approximately $200 billion in counterfeit drugs each year. By enabling complete visibility and transparency across the entire drug supply chain, blockchain will allow drugs to be traced back to their point of origin and therefore help eliminate counterfeit drugs, reducing lost revenue by up to $43 billion annually for pharmaceutical companies, says Beer Research in its new market intelligence report titled Global Blockchain and Healthcare Market Analysis and Forecast, 2017 to 2025. Blockchain technology could be an excellent solution to improve data provenance, integrity, functionality and, of course, supply chain security for pharma. In fact, there are already several blockchain use cases for improving the healthcare supply chain, as well as optimizing the efficiency of the Internet of Healthcare Things, IoT, securing Internet-connected medical equipment, combating counterfeit drugs and much more. One of the biggest challenges affecting the pharmaceutical supply chain is counterfeit medicines. These counterfeit drugs are the result of poor manufacturing practices and techniques, inefficient storage, drug theft and market penetration of low-quality or counterfeit products in so-called gray markets. In fact, the WHO, World Health Organization, says this counterfeit drug market is worth about $75 billion, but the figure could be even higher in reality. This is especially true in countries like Bangladesh, where the vast majority of spending on medicine goes to import suppliers. Of course, the pharmacy supply chain is susceptible to counterfeit drugs not only in low-income and developing countries, but also in more developed countries. In this context, pharma companies may want to team up with mature blockchain technology companies to design, implement and manage their drug supply chains. The collaboration between global pharmaceutical giant GlaxoSmithKline and blockchain company Viant is a great example. It's a partnership that will help facilitate the adoption and use of blockchain-powered tracking technology to secure the pharma supply chain. Managing drug testing data for research purposes. Managing and accessing drug trial data is a recurring problem in the healthcare industry, and even more so for pharmaceutical companies. Most pharmaceutical companies maintain their drug trial data in centralized databases that must meet a number of strict confidentiality and other ethical and regulatory requirements. The problem is that these centralized databases make it difficult for researchers and drug trial leaders to share data with the right people. That's where blockchain comes in. Blockchain in healthcare helps the pharmaceutical industry create distributed, unalterable and auditable databases to store and access drug trial data. We can take the MIT Enigma system as an example. It is a full-fledged blockchain initiative that uses two central cryptographic blocks that work in tandem over a peer-to-peer network of nodes. In simple terms, this system is a secret sharing platform that allows researchers to maintain a high level of privacy and security when dealing with clinical trial data. Improve clinical trial accounting. Keeping up with accounting and costs during clinical studies and/or trials, especially those lasting long periods, is a well-known challenge for pharmaceutical companies. Currently available accounting tools are too complicated and do not show the real complexity behind clinical trial costs. To make matters worse, estimated financial accruals from clinical trials can become an almost impossible mission when it comes to harmonizing accounting ledgers. The good news is that blockchain technology can be implemented to track clinical trial finances, as well as make accounting efficient, accurate and easy. Because of the inherent complexity of clinical trial finances, companies like Boehringer Ingelheim have announced that they will work with blockchain firms to streamline their accounting and financial reporting activities. The same company announced in 2019 a partnership with IBM to use blockchain for clinical trials. This collaboration, which is the first of its kind in the pharmaceutical industry, will produce a new blockchain solution to improve the quality of clinical trial processes and record keeping. The clinical trial ecosystem is very complex, involving different stakeholders, resulting in limited trust, transparency and process inefficiencies without true patient empowerment, said Uli Brodel, Boehringer's now head of global clinical operations, explaining the need for the blockchain-powered solution. Finding the right people for a medical trial faster. Pharmaceutical and healthcare facilities spend a great deal of money and a lot of time finding, qualifying and onboarding the right candidates for their clinical trials. And since only 10% of new drugs reach the market, it is critical to identify and recruit the best possible candidates. Currently, there are several different software and technologies used by pharmaceutical companies to perform this process. Unfortunately, these types of tools do not always identify the right patients, hence the need for blockchain technology. While blockchain technology itself might not do much to correct patient identification, it can help bring some of the data integrity, accessibility, security, privacy and interoperability that pharma needs. Regarding the latter, from a consumer and pharma point of view, several blockchain-based marketplaces have already been launched. In the case of 4Medica, blockchain technology is used to make patient clinical matching more efficient, more cost-effective and faster. Technically, blockchain itself is used to track each patient's unique identifier. It's a central place to keep track of all these identifiers, make it easy for pharma professionals to match patients to their clinical trials. But there is a second use case. Today, researchers try to find the right candidates for drug trials through patient IDs mapped to EHR, electronic health record, data. This process is done almost manually, so it can be susceptible to losing potential candidates during the process. The use of the blockchain would bring the potential loss of potential candidates down to zero because all of their information would be recorded and accessible to researchers. Healthcare institutions and providers. Managing patient data, complying with regulations from regulatory bodies, and keeping up with new directives as they emerge is not an easy job for any healthcare-related organization. The whole process can be tough, tedious, and inefficient, not to mention the considerable costs associated with it. In fact, according to a survey conducted by KPMG, 38% of major healthcare facilities say that improving electronic health record, EHR, management is one of the things with the highest priority and where the largest budget is going to be invested. That said, blockchain can help improve interoperability, security, accessibility, compliance, management, and sharing of patient data in many ways, including 1. Consent management. Forward-thinking healthcare facilities, practices, and providers can pave the way for consent management by leveraging blockchain features. Currently, the entire process of acquiring and managing consents from patients is a very laborious task where it gets lost and very inefficient in any terms. In addition, it has to comply with a very strict set of rules on data protection and patient privacy. This is where Health Verity is transforming the way modern healthcare institutions make critical and defining decisions, especially when it comes to handling patient data. Health Verity has developed a blockchain-based platform that serves as a stage for rapid generation, exchange, and management of patient and healthcare data. More importantly, the technology platform ensures compliance with the regulatory framework by establishing a shared, unalterable record of all patient consent transactions that occur within a healthcare facility. In this way, only parties with express permission can access patient data on the fly without compromising their security and consumer privacy. It is also worth noting that the Health Verity platform eliminates other challenges such as data inconsistency, ambiguities, and fragmentation. The result is a robust consent management system that facilitates the collection of relevant patient data while complying with all patient data protection and privacy regulations. 2. Filling out forms for hospital admission. In countries like the U.S., the hospital admission process is another aspect that needs a lot of improvement due to the way it is managed, where patients often waste time waiting in lines and filling out the necessary forms. That's why blockchain companies like Calibrate Blockchain are looking for ways to change things for the better. The firm has developed a blockchain engine called Universal Patient Index for its Form Drop mobile app. What this mobile app does is allow hospitals to use a blockchain solution that allows new patients to fill out forms before going to the hospital to avoid queues and wasted time. It is really a significant breakthrough for healthcare institutions in countries that require these types of procedures and are looking to improve workflow and facility efficiency. 3. Smart contracts. There is a plethora of contracts in the healthcare sector, between patients and hospitals, between various healthcare providers, between healthcare organizations and providers, and so on. All of them could also undergo a revolution with something we have seen before: smart contracts. We can put two use cases of smart contracts in the healthcare sector. B2B, business to business, smart contracts. Smart contracts can help process, receive claims, and send payments. That's where smart blockchain companies come into play, helping to design smart contracts between healthcare organizations and insurance providers. The blockchain-based smart contract system created by Tibco Software in collaboration with Change Healthcare is a good example. This system enables healthcare payers to automate processes across the claims and transactional lifecycle. Called aptly Project Dovetail, the smart contract platform uses Intelligent Healthcare Network's blockchain technology and Tibco's smart contract project to deliver seamless, secure, and verifiable healthcare transactions. Another great example of B2B smart contracts in healthcare is the collaboration of Minute Clinic, PBM, and Caremark. The CVS Minute Clinic CVS smart contract system was designed to make medication dispensing, clearing, and payment processing a breeze. Patient hospital contracts. Currently, some hospitals must use a number of complex systems to automate various aspects of healthcare transaction processing. Some of these systems are currently riddled with loopholes and sometimes require human intervention. This not only wastes time, but can also be costly. Smart patient hospital contracts, on the other hand, present a more efficient, cost-effective and simpler solution in which self-executing contract rules can simplify the recording and monitoring of something as simple as a patient's visits to his or her physician. 4. Physician credentialing verifications. Hashed Health is a company that uses blockchain to ensure that only doctors with official qualifications are part of the healthcare ecosystem. They built a credential verification system for doctors to prove they are licensed to operate. Hashed Health partnered with Accenture, WellCare, Spectrum Health, National Government Services, Hardenberg Group and HealthLink Dimensions to create a blockchain-based credentialing system. The solution is actually an exchange platform that provides hospitals and other healthcare institutions with access to verified credentialing information, as well as a means for them to provide verified information that can be shared with all other healthcare organizations. Participating healthcare organizations can define particular rules, data and validation checks for credentialing any type of employee, from nurses to physicians and other specialists. Ultimately, the blockchain-based platform helps physicians and healthcare organizations alike save time and comply with different regulations. 5. Securely secure and transfer data. Today, there are thousands of smart devices that collect a wealth of vital user information. Devices such as Omron Heart Guide or Apple Watch collect a variety of crucial data, from sleep patterns and blood pressure to physical activity, heart rate and much more. This is an enormous amount of sensitive data that can be harmful if it falls into the wrong hands. For example, in countries without public health care, a device showing that the owner of the device is not exercising and taking readings that could be interpreted as heart malfunction could end up leading to health insurance for that person increasing exponentially if that information were to fall into the hands of insurers. As such, the security, transmission and privacy of this crucial information must be protected at all costs. One of the effective ways to do this is to use a blockchain approach that allows for the secure recording, transmission and exchange of this information between devices and healthcare providers. 6. Incentives for better health. The Cigna Healthy Rewards program is a program that helps network members get discounts when they sign up for weight management and nutrition programs, gyms and fitness clubs, as well as get vision and hearing screenings, seek alternative medicines such as acupuncture, sign up for mental and body wellness programs, or purchase vitamins, health and wellness products. Blue Cross Blue Shield announced that it will offer deep discounts for Fitbit products to its 60 million members. The partnership with Fitbit is intended to help consumers create and maintain healthy habits, according to Healthcare Wiki. 7. Improve medication adherence. Adherence, in medicine, is the patient's adherence to the treatment prescribed to him or her. Not only is medication adherence crucial for patient safety, opioid overdose prevention and overall wellness, but it can also present enormous cost-saving potential for healthcare institutions and providers. In fact, improving medication adherence can lead to cost savings of more than $290 billion in the United States and €800 million in the United Kingdom, according to studies by the New England Healthcare Institute and the University of London School of Pharmacy, respectively. There are already blockchain firms such as GuardTime that is using this technology to ensure medication adherence. GuardTime, the UK-based healthcare technology firm, along with industry collaborators Healthcare Gateway and Access Medical, has launched MyPCR, the world's first blockchain-powered personal care record, PCR, platform. The MyPCR platform not only automates medical adherence verification, but also ensures the integrity and provenance of patient data, as well as efficient management of GDPR patient data rights, consent. It is currently available to over 30 million NHS patients in the UK. Consumers and providers. So far, we've talked about blockchain only in the context of what this revolutionary technology can do in the B2B healthcare context. However, there are also huge opportunities for blockchain to completely redefine the relationship between consumers and healthcare providers in the marketplace. Let's take a look at how consumers are benefiting from blockchain adoption in the healthcare sector. Medical record management and sharing. Access to complete and accurate medical records across healthcare organizations ensures effective disease diagnosis and more efficient patient care. Since medical records currently reside in centralized databases, blockchain can help ensure that patient data can be transferred from one healthcare institution to another efficiently, securely, accurately and reliably. This comes in the form of the Decentralized Medication Management System, DMMS for short, a comprehensive platform that leverages blockchain technology to manage the access and exchange of patient records. According to Blockchain Healthcare Today, DMMS is realized as a decentralized network under the Hyperledger framework. Based on the network, we designed an architecture within which each prescriber can create prescriptions for each patient and perform queries on historical prescriptions accordingly. A classic example of a DMMS platform is Medical Chain, based on the Hyperledger blockchain that allows patients to give access to their medical records to specific healthcare providers. For later, the registered healthcare professional interacts with the patient's data in an immutable, secure, and transparent manner. In practice, Medical Chain shares electronic medical records, as well as allowing users to sell their data to researchers. This medium would also be a breakthrough when it comes to treating people in other countries. If necessary, any health professional who needed it could access the patient's entire medical history from any country, shortening the time required for clinical analyses that can be critical in certain circumstances. Selling medical data. Researchers are always looking for the right medical data to support their findings or inform their research activities. To gain access to the right patients, research companies often go through intermediaries, typically healthcare marketing firms that find the right patients with the right health problems. That's where blockchain companies like Emblema can come in handy. What Emblema is doing is getting rid of the middleman, but also allowing patients to own their data and find someone who wants to buy it. This helps both pharmaceutical users and end users who can now monetize their data and not have it acquired in questionable ways and methods by many corporations without patients being aware of it. In the UK, for example, only a third of patients know how National Health Services, NHS, uses their data, and only 16% and 18% of them know how their medical data is used by commercial organizations and academic researchers respectively. This is something Emblema seeks to rectify. But Emblema is not the only blockchain initiative aimed at decentralizing and selling patient data. Humanity Co. is another blockchain-based application that allows users to sell their medical data to researchers and large pharma directly by eliminating the middleman. And this is not exactly a market that is in decline. The patient data market is estimated to be worth between $150 billion and $200 billion. Patient Sphere, meanwhile, uses a mix of AI and blockchain to consolidate and help users derive revenue from their patient data. In September 2018, Humanity Co. also announced the adoption of IBM's blockchain platform for its global consent ledger to manage personal data ownership rights. Blockchain technology applied almost any branch of the healthcare industry promises to be the expected solution to help solve some of the most pressing problems that all healthcare and pharmaceutical industries face on a daily basis. It is also true that not everything is perfect and that it may present some problems. However, the list of benefits is so devastating that it dwarfs any doubts that may arise about its application. Blockchain Course Unit Number 14, Blockchain in Transport and Logistics. A curious paradox is occurring in the transportation and logistics (TANL) industry when it comes to applying blockchain technology. By increasing transparency, these distributed digital ledgers can mitigate the distrust that often exists between parties transacting in the industry, but conversely, that same existing distrust makes it difficult to create an entire blockchain system where everyone is present. The paradox is reflected in the slow rate of blockchain adoption revealed in an October 2018 BCG survey of executives from more than 100 TANL companies. The vast majority of respondents, 88%, believed blockchain will settle into the industry at least slightly. And the majority, 59%, believe this settlement will take place in the next 2 to 5 years. But nearly three-quarters, 74%, said they were only superficially exploring opportunities or had even considered blockchain at all. The most cited barriers to broader blockchain adoption are a lack of coordination among industry players, limited understanding of the technology, and a lack of in-house capabilities. The TANL industry is plagued by sources of friction, including myriad suppliers, dozens of deliverables, and ever-changing regulations, which introduce non-value-added costs and can result in inaccurate or misrepresented information. By providing an immutable single source of truth and enabling process automation, blockchain can address many of the industry's pain points such as traceability and security of cargo, speed of processes, and security in payment and billing processes. These benefits can help companies in the industry substantially reduce operating costs, giving them greater profit margins from doing business. Companies can even use blockchain to develop entirely new business models, such as those related to virtual global networks, pooled fleets, and on-demand staffing. Given the dynamics of the industry, no TANL company can do it alone, so it is absolutely necessary for all stakeholders to collaborate in order to put in place a blockchain ecosystem that builds trust for all parties and generates mutual benefits. Each company must also work with suppliers, customers, and even competitors to understand and implement solutions that address their specific business needs. TANL and the blockchain. Investors are aggressively supporting opportunities to develop blockchain applications for Tandl. An analysis also by BCG found that, since 2013, venture capital investors have invested approximately $300 million in startups offering blockchain solutions relevant to Tandl, including $53 million specifically in shipping and freight management, as well as trading and shipping platforms. In addition, Tandl companies have invested millions of dollars in researching and developing their own blockchain solutions. The recent growth in investments suggests that new solutions will reach the market in the next 1 to 3 years. The question is whether companies will adopt them. Major Tandl players are beginning to explore ways to capture value using blockchains, both individually and from cross-industry collaborations. Notable examples include the following. A consortium of 9 companies is developing a blockchain-enabled platform called the Global Shipping Business Network, with the goal of improving speed, transparency, collaboration and promoting digitization. Participants include carriers, CMA CGM, COSCO Shipping Lines, Evergreen Marine, Oracle and Yang Ming, DP World, Hutchison Ports, PSA International and Shanghai International Port, and a software solutions provider, Cargo Smart. Anheuser-Busch InBev, Accenture, APL, Kuhn plus Nagel and a European customs organization are collaborating on a cross-industry initiative to explore the application of blockchain to support documentation handling for maritime freight forwarding. Maersk and IBM have jointly created TradeLens, a blockchain-enabled shipping solution designed to promote more efficient and secure global trade. The goal is to support information sharing and transparency across the value chain and foster innovation. The Blockchain in Transport Alliance seeks to drive blockchain adoption across the industry. The alliance is a consortium of approximately 400 members spanning the Tandl, consumer goods and technology sectors and includes both established companies and startups. But, as the survey results indicate, most industry participants have not considered the potential applications of blockchain. The opportunity analyses make it clear that companies should be willing to invest time and effort to apply this type of technology, as it can ameliorate a wide variety of weaknesses that impede information sharing and create costly inefficiencies. Blockchain can help the industry address these weaknesses by providing an immutable shared data repository, promoting trust among participants and enabling automation of repetitive processes. There are several applications where blockchain would give added value to the Tandl industry, such as goods origin control, end-to-end status tracking and payment and invoice management. These use cases illustrate how blockchain can address industry pain points. Origin of goods. Various mechanisms, including long-term trust relationships, government regulations or rigorous certification processes, serve as proxies to verify provenance. The use of blockchain obviates the need for these nexuses and associated costs. By registering materials, parts or products on a blockchain, participants can verify where these items originated and improve quality assurance. Leading companies and startups are exploring applications of this use case in a variety of industries. De Beers is a good example. The company has worked with BCG on a blockchain-based solution to track diamonds from mine to finished pieces of jewelry. Although this platform, called Tracker, was initiated by De Beers and is currently in the pilot stage, it will become a solution for the entire diamond industry. A diamond tracked on Tracker carries a digital fingerprint with reliable information about its origins and qualities, as well as critical transaction data, such as ownership transfers and processing. Tracker will help jewelers give the end customer confidence that the diamond has been ethically sourced and processed. The platform also allows users to leverage their digital assets and build various types of new businesses on top of it. Such businesses could include diamond-backed financing, compliance services or marketplace exchanges for consumers, services that are not possible without the ability to digitally track and verify each stone. Another example is a startup called Provenance, which is working with Indonesian fishermen to use blockchains and smart tagging technology to verify sustainability claims regarding the fish they bring to market. These applications allow companies to not only increase the efficiency of supply chain processes, but also improve compliance and support a brand's reputation and quality, which ultimately protect premium price points. End-to-end status tracking. To enable efficient coordination of counterparties and just-in-time deliveries, supply chain participants demand real-time visibility into the status of assets or freight in transit. Although a coordinator, such as a delivery service, can provide status updates, it is difficult to keep track when deliveries are made between parties with no prior transactional relationship. In addition, parties have incentives to retroactively manipulate data, for example, by making it appear that goods were delivered earlier than they actually were or that damaged goods were not under their control when the damage occurred. By creating a unique identifier for each product, blockchain enables status tracking among multiple parties and prevents retroactive manipulation of data. Leading companies are pursuing initiatives to capture the benefits in their supply chains. For example, Walmart is now requiring lettuce and spinach suppliers to track the movement of produce from fields to stores using a blockchain database developed by IBM. Invoice and payment management. Because multiple parties involved in Tandle transactions maintain their own records and ledgers, invoicing and payments are mostly paper-based processes that often involve manual data entry. To check for errors and inaccuracies, and potential fraud, companies must perform a time-consuming reconciliation step before payments are posted. Blockchain can be used to store and share digitized records and create smart contracts that automatically execute invoices and payments. Automated processing reduces settlement times, ensures accuracy and detects fraud, while eliminating the need for middlemen and paper-based processes. For example, a startup called Cargox has launched a blockchain-based shipping list platform. Its features include smart contracts and automated point-to-point payment execution. Considering the magnitude of the potential benefits, blockchain adoption by the Tandle industry has been slower than might be expected. Adoption has been hampered by the same obstacles related to coordination and trust that the technology would help the industry overcome. That, in essence, is the industry's blockchain paradox. To resolve it, stakeholders must understand how the following two industry characteristics are inhibiting blockchain adoption. Fragmented value chain. The highly fragmented value chain of multiple unrelated parties makes the industry suitable for blockchain applications. But this fragmentation also hinders the adoption of a common blockchain standard. Of the executives surveyed, 60% believe that the biggest barriers to blockchain technology adoption are the absence of a common ecosystem and the lack of understanding among all the parties that make up the industry itself. Fragmentation also prevents the selection of a common technical standard. The absence of such a standard means that blockchain applications carried out by companies and consortia as independent initiatives are unlikely to be compatible with each other. The limited scale of these initiatives increases the cost of adoption and decreases potential returns. The challenges of the fragmented value chain are compounded by regulatory complexity. Tandle companies typically operate in multiple countries and jurisdictions with varying, and often complex, regulatory requirements. More than one-third, 35%, of executives named regulatory compliance issues as a major obstacle to blockchain adoption. Limited trust. Because Tandle is a highly competitive industry, participants may be reluctant to share information. To overcome their trust issues, Tandle firms have traditionally relied on long relationships with other participants in the value chain, including intermediaries and brokers. Many companies are unwilling to share information outside of these established relationships. In fact, many companies take advantage of information asymmetry to generate revenue and profits. As a result, a substantial number of stakeholders are reluctant to abandon their relationships and give up their information advantages in favor of blockchain solutions. Lack of awareness of blockchain technology and its benefits appears to be a major obstacle to leveraging it and overcoming trust issues. BCG's survey found that only 16% of Tandle executives feel they have a clear understanding of blockchain technology and its implications for their industry. In line with this, only 20% of respondents consider blockchain to be among their company's top 10 strategic priorities. Underinvestment in technology and a lack of deep digital capabilities are likely the biggest contributing factors. For Tandle companies to trust blockchain and change their current ways of working, they need to better understand the benefits and applicability of the technology. But, as we have seen, in recent years, many companies are starting to become aware of the great potential blockchain has for their business and are investing heavily in adapting it. Carrefour announced at the end of 2018 that it would launch in Spain the first food traceability system based on blockchain for one of its products, free-range chicken. In this way, and thanks to the blockchain, it allows strict traceability of the item at all stages of production, processing and distribution. To do this, it used the IBM Food Trust Open platform of which, in addition, Carrefour is a founding member, and the services of IBM and the collaboration of the food company Corin. Blockchain Course Unit Number 15, Blockchain and Data Warehousing. The future of data storage is increasingly on the blockchain, not so much because it is still cheaper than the services we have today but because it is cooperative. Like Airbnb or Uber, they use the excess capacity of all the systems in the world to bring down the cost of data storage to another scale. Today, it is already possible to combine the efficiency and reliability of the cloud with the decentralized security and control of the cooperative cloud storage model, all of which makes it the basis for yet another revolution in data storage. Cloud storage has taken over the market for one reason: the cost per terabyte per month has dropped dramatically over the past few years, and therefore companies no longer need to build and maintain their own server systems, pay for backups and maintain the group of experts it takes to keep it all running. However, the downside is, even though the costs are significantly lower and the convenience of the system has improved, companies are actually entrusting all their data to third parties with all that entails. The true cost of storing data. Compared to decentralized data storage systems, cloud storage is quite imperfect. First, because we only have traditional systems as a frame of reference. Secondly, we tend to think of data security as a matter of redundancy and uptime and forget the issue of data encryption. Thirdly, we almost completely ignore the fact that, as we mentioned at the beginning, data is in the hands of third parties. Thanks to flexible contribution, several companies are able to rent out their redundant storage, and the compounding effect of this practice will further reduce costs on all fronts. Data security is made possible by geo-distribution algorithms. Data is stored everywhere in the cloud, which means that there is no single intermediary. This translates into total decentralization and true redundancy, complete privacy, and a 1000% reduction in costs. Prices for blockchain storage companies are already lower than the big players currently dominating the market with products such as Amazon's S3, Microsoft Azure, and Google Cloud. Blockchain storage, $10 per month. Amazon Web Services, $115 per month. Microsoft Azure, $120 per month. Google Cloud, $100 per month. These low costs continue to improve due to increased adoption, as the market is experiencing drops of up to 800% relative to traditional cloud storage systems. On top of all this, speeds have increased tenfold, so the improvements brought by blockchain-based data storage are huge. Benefits in the industry. Let's review some of the major benefits blockchain brings to cloud storage. -100% private. Blockchain storage systems break data into chunks, encrypt the data, and distribute it across a decentralized network. The user holds the keys to the data, and therefore only the user has access to it. Redundancy. Your files are stored on hundreds of nodes around the globe. There are no failed hard disks, the uptime is practically 100%. Cost downward trend. As the number of nodes increases due to the adoption of this technology, prices will decrease due to the increase in supply. Open source. Most of the systems are built by communities of experts with common ideals where they seek to enable everyone to share the benefits of a more connected and free internet. Immutability. This is one of the most useful features of a blockchain data storage system. As we already know, this means that once a record is placed on the blockchain, it will be there forever along with the date and time the record was made. Examples of platforms. To conclude, let's look below at some examples of companies that are using blockchain to offer decentralized storage. Big Chain. Cloud storage with high volume and very fast transactions. Built on the Rethink DB cluster and uses NoSQL mechanisms to store blocks, thanks to which it has high fault tolerance and capacity. All big chain network members are connected to a single cluster and have full rights to record, change, and delete information, so this case is not suitable for public solutions. But it can be used for private corporate tasks such as account statements, asset tracking, or financial data. Storage and SIA. These are companies that operate as trading platforms. They promise cheaper, faster, and more secure storage. They profit not only from rental fees, but also from commissions to perform transactions related to data uploading and extraction. Storage and SIA scheme of work is, in fact, a mediation between those who bid for hard drives and those who rent them. Blockchain is used for recording transactions, financial calculations, and authentication of files in databases. At the same time, user data is stored outside the framework and can be deleted or become unavailable at any time if the owners decide to delete it. TiesDB. TiesDB is not formally a blockchain, as it is just a decentralized cloud storage that uses smart contracts to motivate and punish participants, store mutual agreements of participants, as well as store information about insurance rates and deposits. In addition, TiesDB uses blockchain to reconcile conflicting information about database changes and related financial transactions. For example, if product information is stored in TiesDB databases, information about the quantity of goods must also be entered into the database. If this is not done, the buyer may pay for goods that are no longer in stock. Filecoin. A platform based on the same practices as storage or SIA. The only difference is in two details. 1. The platform is intended to stimulate the joining of medium-capacity nodes in order to avoid the threat of centralization by high-capacity nodes and instability by lower-capacity ones. 2. The system will try to find nodes to store data as close as possible to the users who lease them. This will increase the speed of uploading and downloading, as well as reduce the probability of errors during data transfer. Using these innovations, as well as a unique consensus mechanism that stimulates an increase in online disk space, Filecoin intends to bypass Google and Amazon in terms of storage capacity in the coming years. MadeSafe. The main idea of this solution is the creation of a fully encrypted peer-to-peer network, which will be a database for the anonymous exchange of information through encrypted layers. This will be possible thanks to three key elements of MadeSafe. 1. Self-encryption. Data that encrypts itself. When a file is uploaded to the MadeSafe network structure, it is split into many small fragments that are automatically encrypted and distributed across the network. At that point, the file becomes unreadable to everyone except the owner. 2. Distributed data caching. Data from the safe network will be stored around the world, rather than on servers in a single company or network of companies. This will make the platform autonomous and increase the level of information security. 3. Data availability. The network constantly creates and maintains duplicates of all the files it stores. This function leads to redundant information, which must be protected from loss due to the shutdown of individual nodes. Blockchain Course Unit Number 16, Blockchain in the Collaborative Economy. The collaborative economy has facilitated a significant transformation for a variety of industries. The most well-known examples are Uber and Airbnb, which have become giant companies, even though they don't actually own any assets. On closer inspection, Uber doesn't actually own the cars and Airbnb doesn't own the accommodations. Their business has been made possible by people voluntarily lending their own assets in exchange for access to their large pool of potential customers. Simplified, this means that the value of sharing services is created by linking people with other people. But creating a true sharing economy is not about selling but about sharing. The problem with the sharing economy is that there are a few large companies that dominate the market. While these companies provide a decent user interface to connect people, people cannot communicate with each other outside of the platform without violating the terms of service. Not only do the companies have the power to dictate prices, but of course they take a fairly large share of the profits from a supposedly peer-to-peer system. Another disturbing case is that of security and crime. Although, thankfully, such incidents only occur rarely, there have been reports of 103 U.S. Uber drivers accused of sexual assault or abuse, while nearly one-third of them had prior criminal convictions, as reported by CNN in 2018. Similar cases have been reported among ride-sharing companies such as Ola in India and Grab in Malaysia. While platforms like Airbnb have background check processes in place and the rest of these companies aim to improve security, verification processes could still be improved. Blockchain technology can help with identity verification and background checks while making these processes more efficient, even going a step further to incentivize behaviors for both good and bad. In addition, the decentralization of databases across multiple nodes keeps data more secure, avoiding many of the vulnerabilities of centralized servers. The peer-to-peer connection enabled by blockchain eliminates the need for a middleman like Uber or Airbnb, which controls user identity and transaction data, which, in turn, would allow for reduced or even eliminated fees for these intermediaries. This allows those with something to share to connect directly with those who want or need to borrow. The parties agree on the price and transfer it securely in cryptocurrencies. Blockchain technology allows that trust and interaction to be created without the need for a central authority, in this case without the need for an Airbnb or Uber. Blockchain-based companies are implementing new mechanisms to facilitate transactions. It enables transparency, automation and decentralization to create a true peer-to-peer system, with no business in between. Because blockchain is based on a distributed and decentralized architecture, its underlying infrastructure grows as more people use the technology. There are a number of projects with the goal of being the blockchain-based version of existing sharing economy services. An example of some projects currently working on blockchain-based sharing are Share Ring. The intention of Share Ring is to aggregate all possible sharing activities under a single platform, which could streamline transactions for the sharing economy. Keep Go is a decentralized mobile data exchange, allowing users to buy, sell or trade megabytes of data worldwide. Origin Protocol. Still under development, it wants to create a platform that allows developers and companies to create their own decentralized marketplaces. Blockchain Course Unit Number 17, Blockchain in Military Applications. Given that blockchain is ever present in any cybersecurity forum or discussion, it is not surprising that military organizations around the world are taking a lot of interest in it in recent years. Secure communications is one example of how blockchain is demonstrating its potential in military applications. The ability to transmit communications securely between units is one of the most fundamental requirements for any military organization, particularly in times of war. Cybersecurity is obviously another huge consideration within the military. However, decentralized ledgers, smart contracts, and other related technologies also offer other great opportunities to solve existing problems within the military space. Military blockchain applications in practice. Military drone technology. In 2018, Google made headlines around the world due to its controversial involvement in Project Maven, led by the U.S. Department of Defense. The project aimed to help the military analyze drone imagery faster using AI and machine learning technology. However, Google employees asked the company to withdraw from the project, and soon after, the company announced that it would not renew the contract it had with the Defense Department, ending its involvement in 2019. Aside from the controversy generated, the convergence of AI and blockchain with drone technology creates formidable possibilities in military applications. In addition to analyzing and reporting on imagery in real time, AI can power autonomous drones. These can fly completely independently, without any intervention or control by a human. Blockchain can record data collected by AI-managed drones immutably and in real time. It can also record flight decisions and actions taken by the drone. Each drone operating is part of a decentralized network, so if it is destroyed, everything it has collected or performed would be accessible by the records it has left on the blockchain. Camera drones have become very mainstream in recent years. However, their first use was in the military. Drones carry out airstrikes and reconnaissance missions that protect military personnel from having to enter dangerous territories. Until now, however, each drone has required a human operator. Using autonomous drones, armies could create true swarms, which would mean having far more firepower than they can bring to human-controlled drones. Blockchain battleships. Battleships are equipped with a wide range of different types of armaments. Weapons of different firepower, but also missile launchers, torpedo launchers, and anti-aircraft batteries. In the face of enemy fire, all these weapons must be able to work together seamlessly. This is based on sensor technology integrated with weapon control systems. The naval vessels of many countries, including the United States, Japan, and Spain, rely on one system to do this, the Aegis Combat System. This system has been managing the weapons system of naval battleships for the past 5 decades. Despite its age, the Aegis is a highly sophisticated tool of military technology. It uses a complex system of radars and powerful computers to make decisions in just 2 seconds. In that time, it is able to control weapons deployment, deciding when and in which direction to fire at external threats. However, it has a crucial weakness: it is a centralized system. If Aegis is destroyed, you can disable the ship. Decentralization therefore has clear advantages for a system like Aegis, leading to speculation that blockchain is the future of battleship control systems. By using blockchain's ability to verify that all nodes are working from the same dataset, the system can coordinate weapons control to neutralize threats. Lockheed Martin is the defense supplier that manufactures the Aegis Combat System. In 2017, the company partnered with Guardtime Federal, which was created in 2014 to exclusively support the cybersecurity and related requirements of the Department of Defense, the U.S. intelligence community, other U.S. government departments, and the industry community that supports these U.S. government organizations. The partnership has enabled Lockheed Martin to incorporate blockchain into its supply chain risk management, software development, and systems engineering processes. The company is the first U.S. defense contractor to implement the distributed accounting technology. It appears that, with this rapid pace of development and adoption, blockchain battleships could soon be one of the military blockchain applications in wider use. Additive manufacturing. Additive manufacturing, AM, is the military term for what most people know as 3D printing. The U.S. military builds prototypes and parts for weapons and vehicles using AM methods. In 2017, the U.S. Navy printed an entire submersible in just 4 weeks. However, it is believed that one of the reasons AM has not achieved widespread adoption across manufacturing supply chains is the absence of a digital thread. A 2016 Deloitte paper defines the digital subprocess as a union of 3 main components: undefined ability to store and reference data, means to identify if a design is not working properly or needs improvement, and the scalability to move the production process forward by applying process improvements using data collected from each previous step. The U.S. Navy has already seen the potential that blockchain can bring to AM processes. Since 2017, it has been committed to integrating blockchain within each step of an AM operation. The use of a decentralized network would meet the requirements of the digital thread. It provides a secure and theoretically unlimited data store, enables data sharing throughout the AM process using network nodes, and could also prove to be an enabler for the widespread adoption of AM in general manufacturing supply chains in the coming years. Blockchain Course Unit Number 18, Blockchain and Loyalty Rewards. Loyal customers are not something to be underestimated by any retailer, whether retail or e-commerce. With the costs of acquiring new customers on the rise and the competition always on the lookout to capture the customers they have not been able to retain, building a strong group of customers who value one brand above all others and are willing to attract their inner circle is a huge advantage. Interesting statistics on the value of loyal customers can be gleaned from a number of different studies. Let's take a look at some of them. According to a study by Adobe Digital Index, repeat customers generate 40% of a store's revenue. -62% of millennial shoppers and 54% of the more adult population tend to buy only their preferred brand. The 10% of customers who have above average loyalty spend 3 times more per order than the average customer, and the 1% of the most loyal customers spend 5 times more according to an RJ Metrics survey study. In general, loyal customers spend more, are more likely to buy when they visit the brand's website, and are more likely to become brand advocates and defend the brand to other potential customers. Since loyal customers are such a valuable commodity, it's no wonder brands are spending more and more to court them. In 2016, of the Fortune 500 companies, a magazine that annually publishes the 500 largest companies, surveyed, 54% said they would increase their loyalty program budgets for 2017 to 2018. For a long time, e-commerce and physical stores have used loyalty programs to encourage repeat business. Traditionally, these programs have been used as a tactic to encourage repeat customers by offering points and discounts. Sometimes with complex cards or registration processes, these programs are starting to fall out of favor with modern customers. Instead of enhancing the customer experience, they can actually have the opposite effect, dampening customer enthusiasm with complex rules and transactional rewards. The hope for commerce is that blockchain technology will revolutionize customer loyalty rewards by eliminating some of the pain points of traditional programs. Let's delve into those pain points and why blockchain technology may be a good option for revamping customer loyalty programs. Customer loyalty programs are in need of an upgrade. In e-commerce, it's usually quick and easy for a consumer to sign up for a retailer's loyalty program. But how many of your customers are becoming loyal brand advocates? Traditional loyalty programs suffer from the following problems. Low redemption rates. Perhaps due to the sheer number of loyalty programs in the marketplace, it can be easy for customers to get lost among them and for points to eventually expire without being redeemed. Surveys show that the average American is a member of 7 loyalty programs, and 30% of U.S. consumers never redeem a single point. High costs. Large retailers, both physical and e-commerce, often pay very high prices to set up and maintain their third-party integrations or custom solutions for customer loyalty programs. Whether they are making adjustments to an existing application or building their own from scratch, development and maintenance fees can range from €2,000 to €15,000 per month for an enterprise-level solution. Few customer incentives. Current loyalty programs tend to favor the company providing them, rather than the consumer. For example, customers are forced to make purchases they don't need in order to earn the rewards. Studies also indicate that 33% of millennial consumers dislike rewards programs simply because they have to carry too many cards. Security concerns. The Harris Poll consultancy found that 71% of consumers were less likely to join a loyalty program that collected personal information beyond just name and phone number. In fact, consumers have reason to be cautious about handing over their personal data. In 2017, 11% of financial account attacks were specifically on loyalty accounts, up 4% from the previous year. Blockchain use cases. Blockchain technology can solve some of these problems with traditional e-commerce loyalty programs by connecting owners and users of multiple programs. This technology can simplify the enrollment process and prevent consumers from having wallets full of rewards cards or passwords to several different rewards accounts. Through blockchain, users can receive and redeem loyalty tokens that are interoperable across multiple programs. These tokens never expire or lose value, unlike traditional reward points. Advantages of this type of system. Open systems. Owning a token on the blockchain cannot be revoked and is publicly recorded on the blockchain. The issuing company cannot take those points away due to any internal policies. This is a win for the consumer who doesn't have to worry about their points expiring or devaluing before they can use them, and a win for companies who gain greater customer loyalty by providing them with a better and more transparent experience. Less clutter. Blockchain tokens can be used in other stores, exchanged for different cryptocurrencies, or stored for as long as you want. More flexibility. With blockchain loyalty tokens, customers have more freedom in how they redeem their tokens. One of the complaints many customers have with loyalty programs are the complex point accumulation systems and limited rewards, so allowing more flexibility in how they use the rewards they have earned is a big advantage. Cost reduction. Program costs will not take years and hundreds of thousands of euros to implement and maintain, because the blockchain already has your own registry. Overall transparency. Users will know that companies can't change the rules or token amounts based on what is in their best interest at any given time. This gives customers peace of mind that they can get what they want, when they want it. Less fraud, more security. Blockchain is based on peer-to-peer systems, which means there is a much lower likelihood of a breach of the program itself or the store's own data. All the information needed for the loyalty program is stored in the blockchain ledger which, as we know, is immutable. Timestamped database entries are irreversible to prevent fraud and transaction manipulation issues. Companies that have already adopted the blockchain. Currently, blockchain rewards programs are not yet very numerous. However, there are already some companies that are paving the way and exploring the potential of the technology for those that will most certainly come next. Here are a few examples. Singapore Airlines. In July 2018, Singapore Airlines announced that its frequent flyer program KrisFlyer would now be reinvented as KrisPay, a kilometer-based digital wallet that members could use to convert those same kilometers into a form of digital payment at other merchants. At launch, KrisPay partnered with 18 businesses across categories ranging from beauty services and food to gas and retail. The press release announcing KrisPay describes it as the world's first blockchain-based digital airline loyalty wallet. Chanticleer Holdings. Another pioneer in the blockchain rewards world is Chanticleer Holdings, an investor in several burger restaurant chains, including BGR, Little Big Burger, and American Burger Company. In January 2018, they announced a partnership with Mobivity Mind, a blockchain architecture platform. As part of their new loyalty program, customers who eat at one of their restaurants now receive a type of cryptocurrency called Mobivity Merit that can be redeemed across brands and traded without fraud issues. American Express and Boxed. In May 2019, American Express announced a blockchain trial program with Boxed. Using a blockchain framework, American Express created a private system for Boxed to transfer information that merchants on Boxed can use to fulfill rewards program offers. Essentially, when a consumer makes a purchase on Boxed, the blockchain stores data about the transaction, while hiding privileged data about the cardholder. The transaction details trigger the creation of a smart contract that then creates and awards points in a back-end loyalty system. Blockchain technology for loyalty programs is still in its infancy, but may cause a major disruption in the industry as more brands explore its full capabilities. Blockchain Course Unit Number 19, Final Conclusions. A cryptocurrency can be defined as a digital medium that is assigned a certain value and can be used as an exchange. These types of currencies use cryptography to validate and protect all their transactions. Cryptocurrencies that have a real equivalent value, or that can be used as a real currency, are known as convertible, Bitcoin being the most obvious case of convertible currency. Some of the advantages and solutions provided by cryptocurrencies are eliminating the printing of money, giving people control of their own money, eliminating third parties, and helping people without access to means of payment. Cryptocurrency exchanges are online platforms where we can buy cryptocurrencies or exchange them with each other. They would be the equivalent of the classic stock exchange or currency exchange centers, for example. Within these exchanges there are different types depending on a series of characteristics: traditional, cryptocurrency brokers, and direct trading. Today, there are thousands of cryptocurrencies, and many of them were inspired by or even directly extracted from the Bitcoin code. Collectively, these descendants of Bitcoins are known as altcoins or alternative cryptocurrencies. The relationship between blockchain and the healthcare sector is one that can and in many cases already does bring very positive things to the healthcare sector itself and thus, directly, to people. One of the first things in which blockchain can help the healthcare sector is in solving the serious problem it suffers in the form of security breaches. However, it is not the only sector where it can provide solutions to existing weaknesses. Other examples are pharmaceuticals, healthcare institutions and providers, and consumer-provider relationships. The transportation and logistics (TANL) sector is one of the sectors that can benefit the most from all the advantages that blockchain brings. However, Due to lack of collaboration within this sector, it is causing its adoption to be much slower than would be expected. Despite this, there are already consortiums such as Global Shipping Business Network, formed by 9 companies, CMA CGM, Costco Shipping Lines, Evergreen Marine, Oakland Yangming, DP World, Hutchison Ports, PSA International and Shanghai International Port, that aim to improve speed, transparency, collaboration and promote digitization through the use of blockchain. The biggest pain points that blockchain can address in the TANDL industry are control over the origin of goods, end-to-end tracking, and invoice and payment management. The future of data storage is increasingly on blockchain, not so much because it is still cheaper than the services we have today, but because it is cooperative. The biggest benefits that cloud storage can take advantage of from the use of blockchain are drastic reduction in operational cost, privacy, redundancy, and open source. But creating a true sharing economy is not about selling but about sharing. The problem with the sharing economy is that there are a few large companies that dominate the market. While these companies provide a decent user interface to connect people, people cannot communicate with each other outside of the platform without violating the terms of service. The peer-to-peer connection that blockchain enables eliminates the need for a middleman like Uber or Airbnb, which controls the user's identity and transaction data, which, in turn, would allow for reduced or even eliminated fees for these middlemen. This allows those with something to share to connect directly with those who want or need to borrow. The parties agree on the price and transfer it securely in cryptocurrencies. The military sector is another major player in society that is implementing blockchain for different purposes. Some of them are military drones. The convergence of AI and blockchain with drone technology creates formidable possibilities in military applications. Battleships. Decentralization of battleship weapons control is a key advancement in current military strategy with respect to security. Blockchain technology can also solve some of the problems with loyalty programs encountered by traditional e-commerce by connecting owners and users of multiple programs. Through blockchain, users can receive and redeem loyalty tokens that are interoperable across multiple programs. These tokens never expire or lose value, unlike traditional reward points. There are companies such as Singapore Airlines, whose frequent flyer program KrisFlyer would now be reinvented as KrisPay, a kilometer-based digital wallet that members could use to convert those same kilometers into a form of digital payment at other merchants. Thank you very much for your attention and congratulations for finishing this course. Share it with your friends interested in the exciting world of blockchain.